with, there we go. Is it okay for record?
Yeah.
Just for ours. All right, cool. We have Pascal Isa. I'm saying that. Is that saying that right? Awesome. Yep. He's a technical lead from Cisco. He used to work with Ronnie Flathers, who's the other individual who used to put on this workshop. But we're really excited. I think I've mentioned to the class that this is probably the best workshop of the entire cohort. I probably shouldn't have said that on recording, but but without further ado, I'll hand it off to Pascal to introduce himself, and yeah, let's get started.
Let me start sharing. All right, let's see. All right, can you guys see? Let me go into. All right, can you guys see? Can you see my screen?
Yep.
Yes, sir.
Yep.
All right, sounds good. So this is an intro to web application security testing. We're gonna focus on a couple of topics that are like very common in vulnerability vectors that we target and pitfalls that developers tend to fall into. We're gonna work with a tool called Burp Suite. There's multiple tools that do this thing, the man-in-the-middle requirements that we're gonna have. And we talk about that when we get there. And then towards the end of the day, we'll do kind of CDF exercises. Ronnie told me you guys are relatively new to web application security. So I figured instead of going full on CTF in a short period of time, we'll do, they're called targeted exercises on specific vulnerabilities and tell you what WebGoat is. And that way you can take that knowledge and actually go and implement it on your own and do further exercises when you go. Because I don't think 2 hours is going to be enough for you. And you know what I'm talking about once we hit that towards the end of the day. My name is Pascal Isa or Pascal Isa. Either way is fine. I'll respond to anything that starts with that letter P. I work for Cisco. I actually work for Cisco in Berkeley. I teach network security course at Berkeley. I lead a team that does security testing for Azure Cloud and Microsoft. Even though we get a lot of assessments and penetration testing, and that like is the official title, 90% of the time I'm just a security guy in a room answering questions of like, how do we do this? Or like, is this right or is this wrong? And then and a small joke in there for you guys. So, all right. OWASP. I don't know, and the problem is I can't see a lot of you guys, but like if you're not familiar with OWASP, OWASP is an open web application security project. It's a project that was started a long time ago. It's a nonprofit. It has chapters all across the planet. All the chapters are active. This is one of the institutions that you rarely see that is constantly active anywhere you are on the planet. Their most famous thing that they're known for is the OWASP top 10. So every 2 to 3 years, they classify the top 10 vulnerabilities that are being targeted in the wild. They have a lot of projects. They have a lot of standards. They have threat modeling tools. They have the SAM, which is basically a standard on working with application security. They have their own tool called OWASP ZAP, which does man-in-the-middle basically for security testing. We will be using Burp just because it's an industry standard. If you're going to learn one, you might as well learn the industry standard. But if you want an as good tool that is also 100% free, ZAP is one of them. They have conferences across the board. I think they have 2 big ones in the US, one big one in Asia, and one big one in Europe. And they cycle, so it's never in the same states and never in the same countries. In Chicago, they had a super active chapter. COVID kind of destroyed that, but I think they're starting to come up from underwater again. They're on meetup.com, so you can go check that out. Typically, you find people like me, Ronnie, anybody in Chicago that does application security. Unfortunately, I'm not able to attend. We're not able to attend all of them, but there's always like really good people that attend these meetings. And it's very good to start connections and actually pick people's brain. Everybody's happy to share. It's like I've never seen a community as open and sharing as the application security people in the US. I have to say that. Okay, security and engineering. These used to be two separate worlds. You were either a developer or a security engineer or a security pen tester. But that in today's world, this is like all coming out the window. I don't know. Is this my hand? Let me do this. So basically, it's changing. DevOps and all that, like agile, high speed development has basically had a greater demand on everybody understanding the basics of security and even having security champions on almost every team. Security has always been viewed as something of a hindrance. It's like, something you have to do. It's the compliance. It's something that kind of slows you down, a hindrance, but it's actually moved on now to be realized for potential of actually saving you a lot of money and effort in the future. And a lot of people have become adoptive of that. And just at any point in time, and you have any questions, once we start getting into it, please stop me. I'd like to keep this as interactive as possible. Don't feel like you need to hold any questions or anything of that nature. Speaking the language, I found is the biggest barrier for people coming into security, because there's a lot of lingo that you hear straight up. Biggest one, see that triangle on the left, is called the CIA triad. It's confidentiality, integrity, and availability. These are the three things that you need to keep in mind every single time you do a threat model. A threat model is basically assessing the security of an object that you have at hand, be it a piece of code, be it a full framework, whatever you're doing. So you need to be cognizant of three things. Confidentiality, can anybody see what's happening on the wire or within the application or in memory, so on and so forth. Integrity, can they change it? Can I verify that whoever said that they were doing it is the person who is doing it? So authorization, authentication, that type of these type of mechanisms. And then availability, right? In a lot of industries, availability is the biggest one, because if you don't have a website, you don't have business. So like, I don't care about the confidentiality, integrity, I need to bring this thing up. So these are the three things that you always have to ask whenever you're assessing a security problem, these are the three things you have to keep in mind. On the right side, you see a typical workflow of a security risk assessment, basically. So everything focuses on the asset. The asset is the component at hand that we're trying to actually analyze or assess the security for. A threat actor, a malicious actor, a hacker, an attacker, it has like a million different names, is a person that seeks to have access without permission. It's basically unlawful access. That's a threat actor. Mostly referred to as hackers, but it doesn't have to be a hacker. It could be somebody within the company that you didn't take into consideration. You trusted all the employees, but you have one of the employees that is not trustworthy, and then they end up abusing their access. So that's a threat actor. Threat actors typically are considered a threat, but it doesn't have to be a person. It can be an entity, a group of people, hacktivism, a million different things in today's world. What they use is something called an exploit. An exploit is code that's written to exploit a specific vulnerability within your asset. Right? So basically, if you've written your code, you forgot a specific thing that is not supposed to be done, let's say SQL injection, if you're familiar with that, that's typically the easiest one to explain. A threat actor will be a threat if they have exploitable code, as in specific piece of SQL that if they run within your application, they gain control. In order to do that, you have to have security controls. Security controls basically either mitigate the risk, so either they stop the risk before it can reach the asset. So you either put a WAF that looks out for that specific SQL code, or you actually patch your actual code, you go and change it and re-release. A security manager or a security engineer is typically the person that is responsible for this. But as we said earlier, in today's world, developers are owning more and more of this, because their code is their baby and they want to treat it with the biggest amount of attention that they can. And then you have management that oversees everything and they own the asset. And then that becomes more, from a management perspective, it becomes more of a financial commitment. So managers, while they worry about the security, they don't worry about it from code or zeros and ones or threat actors. They worry about it from a fiscal sense, as in how much is this going to cost me to patch versus how much is this going to cost me to put a mitigating control versus how much is it going to cost me if actually somebody hacks me. And you'll be surprised how many times they'll sidestep the entire security control because from a financial sense, it's just cheaper to leave it there and get hacked than it is to patch. It's a very sad truth of what we do. Another thing to keep in mind is some controls you can put in place to actually identify threat actors and threats on your network. And this is typically implemented, the identification portion of it is implemented through technology or technology stack, either at the gateways or internally on it. If we take all this and calculate it, this is known as the risk. If a vulnerability exists, the risk is elevated. If the vulnerability is exploitable, the risk is elevated even more. If the vulnerability is exploitable to give the threat actor full RCE, as in remote code execution, then the risk is elevated. If it gives them remote code execution as elevated privileges, as the highest user, like an admin, then that becomes a critical risk, and it increases at the different layers. Any questions on this? I know it's a little complex. All right. Threat versus vulnerability. That's a very big one because they get conflated a lot of the time. We believe as pen testers that it is very important to think like an attacker. If you think like an attacker, you have the space to actually contextualize what you're dealing with, what the problem is, and then you are better suited to actually address that problem. So you have to understand both the threats that exist, as in who is targeting you, who is what is something that can cause you harm. And it doesn't have to be like remote code execution every time. It could be somebody that just like, unplugs the network cable for the company. Like, let's say you wouldn't put the network cable for the company across the hallway because if somebody trips on it, and that can be considered a threat. So a threat can be many things. It's not just code. I just want to make that clear. And then a vulnerability, and the vulnerability is on the other side, something that is typically preventable, but you didn't know about it until you did. And that's why knowing is a big portion of it. So two things you typically do, and you do a lot when you work with security, is threat modeling, as in assessing an entity for any threats. And it's basically a brainstorming session based on different principles. There's now, I think, over 20 threat modeling techniques. I think Microsoft Stride is the most popular one. If you want to look at it, I forget what the acronym stands for. But if you Google Stride, you see it's like basically checking 6 different things at every single piece of your application in order to make sure that you're trying to cover all the risks that can be associated with your application. Vulnerability scanning is basically the other side of the coin. It's basically, vulnerabilities, specific vulnerabilities. You code them into a vulnerability scanner. Burp that we use has a basic vulnerability scanning capabilities. And it basically scans for previously known vulnerabilities against the application that you're currently testing. If you combine both of these together, you will understand what risk is. So typically you ask questions when you're doing a threat model is like, what are the threats to the bank? Like, what does the bank worry about? They worry about money, transfers, and who are possible threat actors. A lot of people will say, oh, people trying from outside the bank. But it could be people in the bank. It's the person who has the keys to the safe. It's the person who manages the cash. It's the security company that transfers the cash from the bank to whatever, Fort Knox or anything of that nature. And then we ask ourselves, what are the controls in place? What pre-existing controls exist? What can we add on top of this? And another very, very, very important thing is, and I can't stress that enough, is what is reasonable? I've seen people in security forget what is reasonable. But that's a major part of security, because if you go outside of reason, people will stop implementing security practices, or at least circumvent them. I give the example of passwords. I think we saw this when we went from easy passwords back in the late 80s, early 90s, where passwords were anything. You can go 1, 2, 3, 4, 5, 6, which is what 80% of people had. And then we said, no, you have to use complex passwords. They have to be 12 characters and they have to be complex, big, uppercase, lowercase. You have to have a digit, you have to have a special character. And then I was a sysadmin back then. And I remember seeing everybody writing their password on a Post-it and sticking it on the screen, which was a perfect example of setting the controls up too high where users circumvented the security control. Any questions on threat versus vulnerability, understanding the risk and threat modeling? All right. Types of security assessments that are specific to applications. Threat modeling, biggest one. It's basically should be implemented at the design stages. I've seen it implemented later on in the development lifecycle. But if you design an application and you don't do a threat model, you are unfortunately doing it wrong. You have to check before you start writing code, typically, what kind of vulnerabilities can exist so you can actually mitigate them or cater for them when you start writing code. Another one is SAST or static application security testing, which is basically applications that check your code for common vulnerabilities that may affect the specific language you're working with. C is notorious for not being able to set memory delimitations. So that's where the buffer overflow comes from, because if your variable is not limited, then anybody that uses your application, they can overflow your variable. They can put more information than it can fit. And that will cause the application to overwrite other areas of the code. So SAST is a very effective way of finding codes, finding bad code statically, as in code that shouldn't be implemented a specific way. There's a million of these tools. Some of them are free, some of them are open source, but like with a license, and some of them are really expensive. They are effective to a certain extent. Dynamic application security testing is an active probe of the application for unexpected behavior. Kind of like a technique known as fuzzing, which is where you throw different random input at the application, expecting the application to behave in a way it's not supposed to. And if you can do that, if you can crash an application or get an application to glitch, then that's when you know you have a potential vulnerability and you go explore that portion of the code. Software composition analysis. In today's world, things are different. Code used to be written from the ground up every single time until people started writing major components of code that are reusable and sharing it publicly. So companies had their own code repos and code arsenals, but now it's like everybody shares it publicly. And I'll give you the example, since I know you guys know Django. You guys use Django all the time, but you don't look at Django's code. It's there, you can look at it, but like 90% of developers will not look at Django's code. And Django goes through iterations and improvements because they keep track of the vulnerabilities and try to patch them. So software composition analysis goes and looks at every single component that you're using in your code and checks if the version has any vulnerabilities, any known vulnerabilities, and then it'll let you know. The only problem with this is if you're not using specific components of the actual third-party component, you might not be vulnerable to that. But you wouldn't know until you actually see the composition analysis and then match that with what components of Django you're using and see if they are actually vulnerable, then you will know if your application is vulnerable. Good thing about software composition analysis, the best thing about software composition analysis is typically it can be integrated in your pipeline. So when you actually push code, it can immediately be scanned and notify you. So you can act early on this. Penetration testing. This is mostly a manual effort. It doesn't have to be. Sometimes it implements everything on the stack. It does software composition analysis, dynamic analysis, static analysis, vulnerability scanning, and everything under the sun under penetration testing. So it can mean a lot of things. But for the most part, when people say penetration testing, they refer to the manual testing part. And the manual testing part, most of the time, exists as either reverse engineering the application if it's unknown source, and trying to see if the code has any vulnerabilities in it. Or if it's a network-based application, like a web application, you do a man-in-the-middle type approach where you set yourself up between the application and the server, between the client and the server, and then you inspect the traffic as it goes back and forth and see if you can manipulate the traffic in a certain way advantageous to you as an attacker. Vulnerability scanning, we spoke about this a little bit. Vulnerability scanning is basically pre-known vulnerabilities that you scan for every time you check a new application. This is inconsistent, but delivers a lot of the time. If there's any major vulnerabilities, you'll be able to find the vulnerability scanning fairly quickly, because that's like, if this has existed before, it goes, checks for it, finds it, and says, alerts you and says, this application has a potential for this vulnerability because we've seen it before. Any questions on this?
In the software vulnerability analysis, if
Yep.
it showed me that that some area of the code that I was not using had a vulnerability, I don't think I'd be very comfortable, because that might mean there's some other area that hasn't been discovered yet, that the supplier isn't reviewing it very carefully.
That is correct. That is right on. Yeah, and the issue with that is, at the end of the day, it depends on what part of the software development lifecycle you are. If the code is pushed, if the application, let's say, is available and online and it's generating revenue for the company, you will see that the company a lot of the time will stick with it and say, this is okay, we'll take the risk, because if we shut down the application, we lose money. If we lose $100 an hour, that's $2,400 a day. So we will try to patch on the back end, but we keep the code running as is for now until we can identify how we can actually remediate this, or change the library that we're using, move from Django to something else. 99.9% of the time, when you find something in the software composition analysis, there's already a patch for it. If there's no patch for it, this is known as a 0-day, and that's a nightmare for everybody involved. People using the library and the people that write the library. Microsoft has had to deal a lot with like 0 days recently because of a nation-state attackers basically hammering Microsoft software. Specifically, Exchange was hit extremely big, where they knew the vulnerability existed, they knew that it was being actually targeted, and they knew that most of their clients were exposed, but they couldn't patch in time. So you can't ask people to shut down their email servers. So that caused a lot of panic. Make sense?
Yep, thanks.
No problem. Any other questions? All right, we're going to talk about penetration testing a little more, because it's going to be our focus. People throw the word pen test or penetration test around a lot, and it can mean like a million different things. Typically, when we say a pen test, it's a scan of some sort. It's vulnerability analysis on the application. And the difference between the names black box, gray box, and white box is basically a black box is an application that you don't have access to the code in any way, shape, or form. But typically with web applications, especially if you're using something like Ajax or any front end code like JavaScript, that is available. So that is still considered a black box, because there's no way to circumvent that. You might obfuscate, but you can't circumvent it. A gray box is where the person asking for the pen test shares some information, portions of code, or some information or infrastructure or anything of that nature. And then a white box is where they share everything, code, any analysis, anything they've had before. A code architecture review is basically just checking the code for the vulnerabilities without actual probing or manual testing. They all intersect on different areas. Compliance is a big driver for pen testing, because they understand that audit controls can only do so much. So they ask to augment that with a pen test. So most compliance or governance GRC modules ask for pen tests as part of it, like PCI, HIPAA, Sarbanes-Oxley, they all ask you to do a pen test at one point in time during the year in order to make sure that the compliance is augmented with pen testing. Attacker simulation basically is where you wanna simulate what would be like with somebody targeting your organization or application without them knowing anything. So attacker simulation is anything that is not transparent to the user that is targeting the application. And this is like scanning, black box, red teaming, network scanning, open source intelligence, credential stuffing, credential dump collection. There's a lot that goes into that area, but we're only gonna cover the application portion of it. Sorry, one more. Bug bounty is a big one for attacker simulation. And if after this you feel like you like security testing and all that, then I would highly recommend you start looking into attacker simulations, bug bounties, to learn how attacker simulations happen and how they fit it all together. Okay, manual pen testing. So it's basically understanding how a web application works, what web application testing entails, know what an attacker looks for and how they do it, being able to manually test for specific vulnerabilities, and you'll find that you learn them one vulnerability at a time. It's not like you know one, you know them all, because their vulnerabilities tend to be vastly different. And then manually verifying these findings or vulnerabilities is a big part of it, because a lot of the time you use some scanning. The scanning will return a lot of false positives. Being able to spot what is real and what is not is a big one. Another one to keep in mind is that analysis, whether static or dynamic analysis, does not understand context. Like sometimes you want the code to do this, but a static code analyzer would be like, oh no, this is like wrong code. You shouldn't do this, and this is part of what you're trying to do, and then that becomes a complex portion of dealing with these applications, and that's why static and dynamic analysis generate a lot of false positives. Like there's a lot of false positives that come out of that. So the idea from this today is be able to empower you to test things yourself, understand how they function, and understand how to test a few of the vulnerabilities that we're going to talk about. And then hopefully you should be able to take that knowledge and advance it to the next level. A few things to keep in mind is with great power comes great responsibility. That's a big one, because a lot of people don't see pen testing as something illegal, but it is. If you don't have permission to test, it immediately becomes 100% illegal. So when you say, oh, I just want to check this one thing on this application that I'm using, it is without their consent, it is considered a massive violation. So you have to approach with caution. Some portions of pen testing are encouraged by companies, but then there are companies that will go after you if you touch their applications without their consent. Even if it's like, oh, I just checked, I didn't get in, I was just checking to see if there's something there. That is something to keep in mind. If you're interested in this, as we said before, bug bounties are a great way. Companies have opened it up for anybody. Hey, come and test. Let's see what you got. And if you get good at it, there's good money in it. Like if you find decent vulnerabilities, they'll pay you between $5,000 and $15,000 a piece. So they do take time to discover, but there's money in that for sure. All right. Are we good? We're good. 30 minutes. Everybody's feeling okay? All right. Understanding the fundamentals is a core component. Understanding how web applications work is a core component of being able to test and check on attacks and vulnerabilities. So basically, a lot of web application security education is based on attacks rather than the underlying principles that exist within web applications. So fixing security bugs feels like whack-a-mole, because a lot of people don't understand how things work, and they end up patching instead of going to root cause analysis, understanding what controls are there in place in order for people to be able to circumvent the actual root cause that causes these vulnerabilities in the first place. So by understanding why an attack works, you can easily understand how to defend against it. Web technology overview. A few things that you need to know, and you need to know hands down. So plain text protocol that powers the web is called HTTP. I'm hoping that you guys have been exposed to HTTP. HTTP is just a markup language. They say language, it's not really a language, it's basically formatting, a formatting language, for lack of a better word. It's well defined, it's accepted by everyone, it's run by almost all web servers, is the same. HTTP versions, there isn't a lot, which is why people like it. There's HTTP version 1.0 and 1.1. Version 2.0 has just started being used in the last 3-4 years, but it's also the same exact thing, except they changed words to actual number representation. So instead of saying content header, you say 02. That's HTTP2, and that's only to speed up the communication so that not a lot of data travels back and forth the entire time. So that's why people like HTTP a lot. It's the foundation of everything that is web. It's generally run over port 80 and 443. I don't know if you got into networking and networking security. HTTP on its own is clear text. So anything that travels over the wire is not encrypted, so anybody can see it. So if you send a username and password, anything of that nature, it can be stolen by anybody along the wire. So if you're at home, it can be anybody that has access to your router, anybody that has access to your ISP, any ISP along the way, any network wire along the way, anybody at the company side. So that's why HTTPS is extremely popular, but it makes sure to cover two things out of the CIA, if you remember. It covers confidentiality and it covers integrity, because it encrypts the data. And then just to make sure that nobody steals that data and replays it, it actually creates integrity around it, as in a check that this data is unique for one point in time, and the sender who sent it is who he says he is. The other thing is HTML we talked about. It's basically just a format. There's nothing to HTML. It's very basic. It's very similar to PostScript, if you guys have been exposed to PostScript or like the earlier PDF languages. It's just formatting languages, like make this bigger, make this smaller, put this in the center, stuff like that nature. CSS was added to HTML, and CSS stands for Cascading Style Sheets. And it's basically make the HTML pretty. HTML is very drab on its own. It's black font, white background. You can customize the colors a little bit. I think there's 4 basic fonts you can use. CSS came in to add all that like flair and design and like on mouse over, change the color from green to whatever, to white and things of that nature. And that all is hosted in the DOM. We live in the DOM when we live in the browser. So basically, every time you load a web application or a web page, it's all loaded in the DOM. Everything, HTML, CSS, formatting, there's a lot that will go with it, and we'll talk a little more about the DOM. Basically, DOM is what you see. This is when you click on the thing, you see a page, everything that's laid out in front of you is the DOM. And every browser has ways that give you that for you to be able to inspect what's happening in the DOM. So I think in Chrome and Firefox, it's right-click, inspect. You can right-click a specific object and inspect, and it'll show you all the details about that specific DOM or application. Any questions on this? All right. So in the world of web, JavaScript is king. So there was a war of languages about 20 years ago where Microsoft had their own language called VBScript, also known as ActiveX, and it has a million different names. There was also a language known as Flash or Shockwave, if you're a little older and worked on the internet in the 2000s. There was a lot of languages that came up. There was Java, was a big one. But at the end of the day, JavaScript, and JavaScript, of course, was there. JavaScript came out a winner. I don't know why. I don't know why developers chose it. I think people didn't like Microsoft's own technology, so they moved away from that. Java was for Sun, and now Oracle, they moved away from that. And JavaScript kind of was like that new kid on the block that wasn't really one company's language. So people veered into it, and now it's ubiquitous. There's still other languages like TypeScript, CoffeeScript, ECMA, and there's like a lot of them, but they all are JavaScript based. They all operate in the same way. They all have similar syntax. So JavaScript is the de facto language to learn if you're going to do anything on the web, and it does a lot. JavaScript also lives in the DOM, but JavaScript has a lot of, basically it has most of the access and manipulations of the DOM. So animation, storage, tracking, checking what you're seeing, scroll rate, how long you stay on a page, like timers, you can do all that with JavaScript. So modern day browsers develop specific APIs for JavaScript in order to do everything. Interact with your camera, like literally everything, like storage, persistence, remember that you were on this page, things of that nature. As Java grew stronger, web browsers started to implement tighter and tighter controls because they realized if somebody takes control of the JavaScript on your browser, they can do anything that you can do with that browser. So they can go to Chase, they can execute transactions on your behalf, they can go to buy tickets at Ticketmaster, anything. So that's why JavaScript, running JavaScript is in the browser, became sandboxed, became controlled. They tried to shrink a lot of its capabilities, or at least limit them to the actual appropriate needs. Does that make sense? Any questions on that?
How is that done? How is JavaScript kept in the sandbox on the browser side?
So it's different browsers do it differently. If I'm not mistaken, today it spins up its own process in memory, so it doesn't have access to the different parts of memory that the browser uses. So it runs in its own memory space with its own components for every single page you use, so that it doesn't even share it with another web page when you open it. So every time you open it, there's a small chunk of memory that's reserved specifically for that web page. But there's a lot more controls as well. So there's, and we'll talk about some of these. There's same origin policy, which basically checks the domain name, the protocol you're using, the path, and all that. There's a lot of different components for JavaScript. There's like nullification on restart. There's a lot of API controls in place and memory controls in place to protect from Java spreading out. And again, different browsers act completely differently. If you want to learn more about that, I think there's a book called The Tangled Web and the browser. One second, I'm trying to read the Browser Hacker's Handbook. I can share those in the chat if you're interested. Because different browsers act completely differently. So there's no one way that's set across the board. The good thing about it is when the browser makers see one browser implement the technology and it's successful, they all replicate. Microsoft is a major example of this. They dropped everything in Edge and they rebuilt it based on Chrome's functionalities. And they've added multiple security controls where Chrome started adopting what Microsoft is doing to the Chromium engine. Make sense?
It does. Thank you.
Any other questions? All right, HTTP, as I said, is plain text. And you'll see, I'm hoping you have seen request response before, but basically a request is get, that there's like a method that's involved. There's, I think, about 8 methods in total, of which people mostly use 5 methods, and they're self-descriptive. So get is get a page, put is put or update, post is very similar, but it's not update, it's put, like as an insert, as a new thing. Delete, which is delete. options, which is what options can I get? What are the header options that I can get? And then head is just give me the server headers that they're going to respond with. These are the common ones. There's a lot more that are less common. Well, not a lot more, about 5 more that are less common. And as I said before, HTTP is plain text, and it's HTTP versions 1.0, as you can see here. It says get / is the root. Protocol is HTTP hypertext transfer protocol version 1.0. And that says I'm using, this is the protocol I'm using. And then the response says, okay, HTTP 1.0, 200, okay, 200. So these are response codes. They're a set of predefined response codes starting from, I think, 200 to 550, I think is the last one. But they're typically spread by class. So the 200 series is okay. So 200, 201, 200, it's like, okay, but you need to do this. 202 is okay, but I'm going to push you somewhere else or something like that. 300s are redirects. It's like, oh, I got you, but I'm gonna send you somewhere else. 301 is this is permanently moved. I'm always gonna move you. 302 is like, okay, this is partially moved, stuff of that nature. 4 is the error series. 5 is the server error series. So you can see this is how it starts, and these are all header content that we're gonna go over just a little bit over some of these, but basically it has date and some control processes that are in place. Another thing to remember is HTTP is stateless, as in every single HTTP request response is independent from the other one and does not know what the other one did. And we will talk how people have, how developers have circumvented this by enabling cookies and certain session persistence through cookies or browser storage. We'll talk about that in a bit. The headers are basically the control units that are either set by you with the requester. You can say, I'm doing this, this, and this. As long as the server accepts it, they'll confirm and tell you what kind of headers they're running. And you can see like cross-site scripting protection, and we'll talk about some of these as well later on. These offer a lot of security. And doing what I do, I've learned that a lot of developers don't know a lot of these exist, because they're typically handed out to infrastructure engineers who set up the servers. So there's a disconnect there, and learning headers, server response headers, is a very important thing. And then you have the body, and the body is basically just HTML. It's just the actual what is going to be laid out on the page. This is processed by the server. This is processed by the browser. This is processed by the browser client that's transparent to you. This is actually rendered so you can see it. And I'm hoping you can see my mouse pointer as I move it. Any questions on this? All right. Another important thing to keep in mind is encoding. When computers were created, everything was based on something known as ASCII. ASCII is a presentation. So in computers, everything works as ones and zeros. And ASCII is a very basic representation of the first 2 to the 8, so 256 ones and zeros. We represent it in hex, and I don't know how like your math with hex and binary is, but that's basically just a representation of ones and zeros. We just put it in hexadecimal because it's easier for people to see. And you'll notice everything is represented in hexadecimal just in order to make it shorter. Base 64 implements mathematical computation on it in order to hide the number to a certain extent. So the way encoding functions is basically a way for the browser or any entity you're working with to understand what you're saying and to be able to decode. So if I say 48 in ASCII, I think that's typically the letter D. And there's an ASCII table. If you want to look at it up, just Google ASCII table. There's also URL encoding. So ASCII only has 56 slots. So it only has, I think, 52 characters, all the US alphabet, the Arabic numerals, and some special characters. And then the rest are like empty spaces, as in like, space, enter, stuff that you can't actually see. As the world expanded, people noticed that different countries have different letters that can be represented with ASCII. This is where URL encoding was born. URL encoding basically does encoding of more than just English numerals. You can, do an accent aigu in French, or like an umlaut in German, or stuff of that nature. So that's why URL encoding is much bigger. While ASCII lives in a 256-bit space, URL encoding lives in a 65,536 space. A very important thing about encoding and different encoding platforms is they're not encryption. People see this and they're like, oh, you can't read this. If I can't read this, this is protected. So confidentiality is covered. But it's not, because everybody in the world knows how to decode. Base 64 is documented, so you can actually run the math and reverse this. ASCII is documented. It's very easy to run the math and reverse this. Same thing for HTML encoding and URL encoding. Some things to keep in mind is like stuff like new line, null characters. A null character is a character that is non-existent, basically. That's what you tell the browser. And in the early days, null characters used to like weird out the browsers in a massive way. They didn't know what to do with it. So if you sent a null character in the middle of your URL or URI, there's a good chance you actually broke how the browser processed that information. So new line characters, tabs, stuff of that nature cannot be sent as is. You can't send the tab as is. It has to be encoded, and then the server has to decode it. There are a million types of encoding. The most common ones you see are ASCII, base 64, URL, and HTML. I would say in that specific order. Any questions on this? This is a world of its own. I'm not going to dive any deeper than this unless you guys want me to. We good? All right. HTTP session management. So because we said HTTP is stateless and every single request response is independent of each other, developers wanted a way to establish persistence. So let's say I, Pascal, visit CNN.com. I click a page and then I click a second page. CNN will treat these separately had there not been a session. So cookies were invented as a way to create a session, like a hack in some sorts of actually being able to establish persistence. So the first time I talk to CNN, the server responds with set cookie, let's say 123, right? And then every time I visit another page, I send that cookie. So every time I sent a get, I sent my cookie is : space 123. So that way CNN knew that this was me, the same user, based on some information like my IP and some other stuff, and the cookie itself. So that's how servers establish sessions, through the cookie hack. Does that make sense? And just to put it out there, cookies get a lot of hate. I love cookies, but like there's in the development world, people have a lot of problems with them, especially since a lot of frameworks now use cookies as entire storage management. Like the .NET framework, Microsoft uses it as a state tracking entity. So instead of the cookie being like, I don't know, 32 characters, it becomes like 600 characters, because it tracks every single page you have visited, and then you can maneuver using the cookie, like back and forth.
Excuse me, I've got a question.
Go ahead.
So a cookie is just utilizing your browser's local storage?
It is, yes.
Okay, thanks.
Yes, it is, and you can view it. You can if you're in a browser and you click inspect, you can see cookies. There's also extensions that are called cookie explorers, and you can see the cookie. And the biggest security risk with a cookie is because it's now used. So you authenticate to the website. The website sets what is known as a session cookie. That session cookie becomes your authentication. The browser isn't going to ask you to sign in every single time. So protecting that part of the storage in the browser becomes very important, because if somebody steals the cookie, they are you to that website. Does that make sense?
Yes, sir.
I hope so. Okay, perfect. So over time, cookies have added some, developers have added some security over cookies. Browsers tend to be designed for the easiest use ever. And they will send the cookie on your behalf every single time, because they think that that's what you want to do, because you don't want to authenticate every single time, and so on and so forth. So that is how state and persistence is established. This is taken advantage of a lot because attackers know that the cookie is being sent every single time. So they try to either masquerade as the entity that needs the cookie, or they try to use JavaScript to steal the cookie from storage, or they try to send you requests in order for you to execute a web page using your own cookie. So, so some flags have been put in place over time, and they're very important. If you say set cookie :123, then /HTTP only, that tells the browser that JavaScript is not allowed to touch this cookie. This is a protected cookie. JavaScript should never touch it. This is between the browser and me, and that's it. Another one was added later on, which is /secure. And that says basically, if the user is running over HTTP, not HTTPS, it's like if it's not encrypted, the cookie is not to be sent. Newly implemented same-site cookie is a little more complex, because that basically says share the cookie as long as it's within the same site based on policy origin and some other factors. It's a new flag, so different browsers implement it differently right now, but it's getting there. I think it's starting to standardize. And that's a problem with adopting new technology. I'll tell you right now, is anytime you adopt a new technology in a web browser, there's always some competition until it evens out and everybody adopts the, like the winning technology. So there'll be some technologies that are implemented and then they die after a while. So that's the sad truth of things. Answering your question, besides cookie, browsers have a storage API. And that storage API is designed specifically for Java in order to be able to, for JavaScript, in order for it to be able to store some components so that it doesn't have to go across the network every single time. So let's say you're doing a query and you're getting, I don't know, the stock listing of like the last 5,000 items. If you were to go and pull this every single time you change the page, that will be a huge network cost. So that's where local storage is there for, or session storage. So this is where the browser storage is there for. So session storage is basically designed to track the session, and it's only available for this window, only for this session. So if you close the window, if you log out, or any of that, that's the one that gets nullified. The local storage is available for everything that's within the same origin. And we're talking about SOP, or same origin policy, and how it applies. It doesn't really apply to cookies and parts and browser storage, but it applies to JavaScript, and JavaScript is what accesses the storage. So in some way, it does apply. So while you can protect a cookie with HTTP only, you cannot protect storage. So what goes into storage and how long you put it in storage is very important, because if at any point in time your JavaScript is compromised, the JavaScript container is compromised, then an attacker would be able to read that data. That said, unlike a cookie, it's not always sent with every single request. So an attacker would need to go and poke into your storage and try to find what they're looking for. Does that make sense?
Yeah, I understand that if I have two tabs open in Chrome and I create some local storage in whatever's going on in one tab, that local storage is available to whatever's going on in another tab.
Yes. Yes. But the same origin policy stops the actual well, yes, it is available. So but the JavaScript of the other website would need to know exactly what to retrieve and how to retrieve it. And it depends if it's session storage, it's not available, but if it's local persistent storage, then it is available. So there's
Sounds
two
like
kinds of
fun.
storage in the browser. So yes, you have to be careful of what's stored in the storage. You can, I mean, the circumvention typically implements some kind of key in the storage. So it's stored, but it's stored encrypted or scrambled, either with a cookie or something else. So that way you make sure that even if the data is retrieved, it's not recoverable. Any other questions on this? You can also inspect storage with tools, and you can even run code to actually retrieve some storage. Are you guys doing okay? Do you wanna break, or should we keep going?
I wouldn't mind a break, Pascal.
Sure. You wanna do 10, 14 minutes? We come back at 10:10. Does that work for everyone?
Yeah.
Yes, sir.
All right. Let's pause here then, and we come back in a few minutes and continue. All right. So HTTP requests can be done two ways. It's basically one is initiated by the user themselves. So you go to the browser, you go www.google.com, you click enter, and then that gets a page and gets loaded one piece at a time. And then in that browser, as you see on the right side, there's some stuff that happens automatically for you. So if you say link style sheet, the style sheet gets pulled and it gets implemented on the web page. If there's any JavaScript, the JavaScript gets pulled so that if any functions are running from the JavaScript, they get executed. If you're calling any images, they get pulled in. And if you're running any frames or iframes, they also get pulled and executed in the same web browser. This is all happens on your behalf in the traditional way. And there's also, if you submit a form, like you say, you're logging in, authentication, you click and you see this change happen. All of these, I just want to make sure you know, include the cookie because they are considered part of the session. So the cookie is automatically sent. So if you can actually gain access to any of these, there's potential for you to gain access of the cookie itself. And then the other way is a JavaScript request. So this was implemented as part of a programming edition called AJAX or asynchronous JavaScript and XML. The actual API call is XML HTTP request. It's I think been updated to fetch. Well, it depends on the JavaScript specifically, which version you're using and how you're coding. I think XML HTTP requests will still be accepted, but they're moving away from that because it's confusing to new developers that are coming in today that don't see it. And it's basically an asynchronous request, as in the request and response don't have to be instantaneous. You can set a request based on an action. You can set a response based on an action. This is all done silently and in the background for you. And if these are misconfigured in any way, they will be abused significantly and are a major cause of allowing cross-site scripting, or a script that runs from another site within the context of that DOM, which is something very bad and you don't want to happen. Do these two HTTP request methods make sense to you? All right. So now we're gonna start diving into same origin policy. So when browsers noticed that basically anybody on the internet can manipulate different parts of the browser, same origin policy was born. And same origin policy takes into consideration multiple things. It takes into consideration the protocol you're using. So HTTP is different than HTTPS. It takes into consideration the domain, the full domain. So www.google.com is different than www3.google.com or ftp.google.com. That's not considered the same website. And then the port. So if you're going to http www.example.com and then you go to http www.example.com :8443, that's a different website. Even though it's the same domain, it's the same protocol, if it's running on a different port, it's considered a different origin. This is very, 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 very important. And I can't tell you how many people mess this up. So on this slide, if you have any questions, please hammer them, because this is one of the biggest fundamental errors that most developers do, is confusing same origin policy. So, and why is this important? Because every site you visit can execute JavaScript within that context. And that context is based on the same origin policy. So if I gain control to something that is existent in the same origin policy, I will be able to execute code in your context. And that is why it's extremely dangerous. So as you all know, any site you visit can execute JavaScript. And then we need to protect that the JavaScript runs in the same context. So this is how the browsers limit it. They limit what JavaScript can execute in the context of the same origin policy. So it's like what APIs you can reach, what cookies you can communicate with, and how you can talk to it. Sandboxing on top of this is implemented so that the browser, the attacker cannot escape the browser and hit your operating system. And in newer browsers, a sandbox is so that an attacker cannot escape the actual tab that they're in, so that they can't even go from tab to tab. Different browsers implement sandboxing different, so that's very important. But for the sake of same origin policy, is the data always has to originate from the same origin. And this is a very important one. Does that make sense?
I have a question.
Sure.
As far as sandboxing on the client side, is it safe to kind of think of it almost like a virtual environment? So you have your security within the virtual environment. So like, even if it gets outside of that, it still can't get out of the environment.
100%. Actually, I think Edge is trying to build a full-on virtual environment within the actual sandbox, within the actual tab. So each tab would have its own virtual environment, its own memory, its own storage, its own everything. So it's going in that direction. Right now, it's not fully there, but yes, what you said is 100% spot on. Any other questions? Again, please remember this: protocol, domain, FQ. So a terminology we use is called FQDN, fully qualified domain name. And that means every single bit in between the slashes. So if it's HTTP : / all the way to the second slash. So that is the FQDN. Anything in between that has to be identical. The protocol has to be identical. If it's HTTP, HTTPS is different. And then the port. Most of the time, the port is 443 or 80, so you don't see it. The browser doesn't show you that. You can try it. If you say google.com, colon 443, the browser will remove the 443. It's like, I know what I'm talking about. You don't need to tell me what HTTP is. But all these three have to match every single time for the JavaScript to execute in the same context. So same origin policy does a very good job of restricting what the JavaScript can see. So let's say example.com is running JavaScript, then example.com will not be allowed to access chase.com's JavaScript template. So they won't be able to access the cookies, the API calls, anything on the web page, and both storages. This is the session local storage. Does that make sense? So that's why same origin policy is extremely important. And we'll talk about cross-origin resource sharing as well later on. But this is something you have to keep in mind.
I have a question.
Yes.
Does this also apply to like, I guess one of those like link shorteners or something like that?
So link shorteners are just forwarders. So what a link shortener does, it'll send you to the next page, but it is a different same origin policy. So the link shortener, the first one you hit, is a completely different website than the second one it pushes you to. So that's just a redirect. So there's nothing executed in the first page that you open. So if you do bit.ly/ whatever, there's nothing there. It just moves to the second page, and then that execution happens in the second page.
Okay.
Any other questions? So if you remember, we spoke about the DOM. Basically, same origin policy makes sure that there's no DOM to DOM jump. Like the document object model for Chase cannot access Google, cannot access any other thing you have open on your web browser. At least that's what it hopes to achieve. And it does a fantastic job of doing this, except people circumvent it because it always stops them from doing their job, which frustrates them, and they end up circumventing this a lot. So if you didn't have same origin policy, anybody, any browser tab you open will be able to see all other browser tabs and interact with them. And that is super dangerous. That's basically every attacker's dream. So basically, if you visit my page, if I can get you to click on one link, I'll be able to read all your bank information. I'll be able to execute transactions on your behalf. I'll be able to read your email. I'll be able to steal all your session cookies and log in as you from somewhere else on the planet. Ronnie actually in the slides goes and writes the code for this if it were true, and he's buying himself basically a MacBook Pro and shipping it to his own address, just because if you load this specific function, which is 4 lines of code, you can actually execute a transfer on somebody's behalf if same origin policy is not in place. Does that make sense?
Scary.
Yeah, very much so. So after we've spoken about this, so cookies are scoped to the domain. They're not scoped to the same origin policy. I need to double check that, but yeah. So basically, a cookie will be scoped to anything except the first part of the FQDN. So if it's like 4 portions, so if it's like ftp.www.example.com, so it'll be scoped to www.example.com. But in this case, it'll be scoped to example.com. So if you're looking at the below, which of these below 5 do you think have the same origin as the https www.example.com/home/homepage?
Is it correct to say that these are all the same domain, but none of them are the same origin because like it's all different? It's not /home and so on.
Yes. Well, one of them is the same origin.
The port is not distinguished in between C and E.
Well, C is 80 because it's running HTTP. HTTP means inherently it's port 80. E, it says it's explicitly saying it's 8443.
Okay.
I would say E probably.
Yeah, I'd agree with B.
Anybody else want to take
Okay, B and C are the same.
So B is actually the correct answer because the protocol match, so it's HTTPS and HTTPS. C is HTTP, so it's eliminated. So immediately eliminated, we don't even move forward. And then we take the full qualified domain name, so FQDN. And then we match the FQDN. This one matches, so B matches, E matches, D and A are eliminated. So we either have B or E, and then we go to port. B is 443, it's inherent, so it doesn't show. This one is 8443, so it's eliminated. So the right answer would be B. So it matches the scheme or the protocol. It matches the host name, specifically the subdomain, which is www. That's the first portion of that FQDN, and the port number. I don't know why they chose with browsers to remove the port number. I think it's just ease of use. The same thing, they removed www. Today, if you type a domain, the browser will automatically append www if the domain doesn't respond. I think it's just ease of, these are all ease of use, but that doesn't mean that they're not there. They're always there. You just don't visually see them. Sorry, there's a couple of things on the chat. Is that how would I circumvent? Oh, okay. I think I've answered that. Does that make sense? Any questions on this one? Okay, so basically how JavaScript gets loaded, JavaScript has to be tagged, so it has to be pulled in to the script. Sorry, pulled into the page. So in your HTML, it has to be referenced. And that's how JavaScript gets loaded. You can load JavaScript from a source that is not yours, but you have to be very careful, because if you pull from an untrusted source, they will be executing their code on your machine. And that's basically what every attacker strives to do, is get you to run their JavaScript within the context of your application. JavaScript can be loaded in a million different ways. If you see over here, in the image, the code specifies source is equal to X. So basically, it's trying to we're trying to get the image tag to actually on error. So we're trying to get it to error. So we set the source to X. We're trying to get it to error, because that's not how the source is supposed to be an image path. And then we say on error, do a JavaScript thing like console log. You can do an alert. You can run JavaScript. And you can see, because it's not found, JavaScript will execute the log error. So there's multiple ways to run JavaScript. It doesn't have to be pulled in. That's the typical method, is you import the JavaScript like you import everything else, but it doesn't have to be that way. Make sense? So understanding web application security, you need to understand like 3-4 concepts extremely well. HTTP, CSS, and everything that comes with it. Sorry, HTTP and the protocols and the network protocols and everything that comes with it, and the headers as well. It's very important. HTML, CSS, and everything that comes with it, and JavaScript as well. I would add to that browser security is something that is very important, and it's typically referred to as the front-end security or client side. Good news is, if you understood even 60-70% of this and retained it, you will be way ahead than most developers that are out there. A lot of people start development without taking any precautions. They hit the ground running, they learn the code, they develop the code, but they don't understand the basic concepts that are behind it. I'm gonna pause. I have to jump on a call. I'm really sorry about this. I should be done about 20 minutes. In the meantime, if you guys can do one thing, or at least try to install Burp. I have a slide for that. All right, I'm just gonna go. Oh man, no. All right, if you can download and install Burp Suite Community Edition, It's on parkswigger.com. That would be great. In the meantime, I should be back in about 15-20 minutes. If you have any questions, please put them in chat. I'll try to get back to them as soon as I'm back. At least download. Hopefully, you'll be able to download. Oh, sorry, I need to answer this. Burp Suite installation is fairly easy. It's just a double-click process. So that should do it. Running Burp Suite is a little more complicated, and I have a bunch of slides on that later on. I'm just going to go back to vulnerabilities. I think we're about to finish the basics of what HTTP is and the basis of the security and same origin. I think we're almost done with that. Just touching on OWASP top 10, and then we can go into the vulnerabilities. It gets a little more interesting from there, I promise you guys. All right, let's go. All right, wait, sorry, I forgot. Did I sharing? All right, any questions before I jump into OWASP top 10? All right, so the OWASP top 10 is a curated list from the industry, and it's updated. Used to be every 4 or 5 years. Now it's getting, I think they're doing it on a biannually every 2 years. And it's basically what OWASP has reported on the different vulnerabilities that have been seen recently. It is no way an exhaustive list. There's a lot more vulnerabilities than the top 10. The top 10 are just the ones that are typically hammered by attackers, and they constitute around 70-80% of the attacks seen online. OWASP does a fantastic job of publishing information, cheat sheets, guidance on all the vulnerabilities and remediations, checks for them. So I highly recommend checking the website OWASP.org and the top 10 and the cheat sheets. They do have a lot of applications as well that help you for threat modeling. I think it's called OWASP Dragon or OWASP Owl, I think, something like that. It helps you draw the diagram of your application and cycle through vulnerabilities and whatnot. Any questions on this? So the latest top 10 include the usual suspects. I think it's changed a little bit, but for the most part, it's the usual suspects. Injection has been, I think, #1 for a long time. An injection is basically anything that you can insert code into that is not supposed to go there. The most common one is SQL. NoSQL has been rising. Command injection and LDAP injection have also been there for a long time. But new SQL injection is a new type of injection that's been coming in fast these days. Broken authentication has been a culprit in the top 5 for a long time as well. People don't set up their authentication properly. Sensitive data exposure like errors, dump stacks, stuff like that nature as well. Cross-site scripting is one of the new ones. Cross-site entity injection is a new one. It's still kind of injection, but it's like XML specific on how the XML processor evaluates XML. This is recent, a recent addition. Broken access control is a culprit. Deserialization is one of the new ones as well, where languages turn your code into binary serialization sometimes that can be manipulated in order to cause it to malfunction on deserialization. There's the usual suspects like security configurations, cross-site scripting, cross-site forgery as well, always hang out in the top 10. Any questions on this? We can break them down broadly into 2 categories. Typically, the injections and serialization tend to be technical, cross-site scripting, injection, XML injection, and deserialization is you inserting code in a place that's not supposed to be and getting it to do what it's supposed to do. So it falls higher on the technical side. The other vulnerabilities tend to relate more to design and configuration, and they tend to basically happen more on the infrastructure side of things. So the technical vulnerabilities happen more within the code itself versus the design, where it's like more the logic or how the application is designed, on how it's hosted, and so on and so forth. Design tends to be a little harder to spot because most of the time it tends to be logical nature. So it is not a syntactical error. It is just an implementation error, which it's a lot of people have the joke running that it is by design, as in I designed it to be like this because I needed to. So any questions on those? All right. Jumping into manual pen testing, we're going to talk about, I think, about four vulnerabilities. We're going to dive deep into each one of these. But initially, we're just going to go on like how it happens and on what sides and how you can actually try to protect against it. Today's world, people think that applications are like super complex. And there's like a lot happening. There's a lot of JavaScript. There's a lot of HTML, a lot of CSS. The code lines like ramp up quickly. There's a lot of visual interface design. But at the end of the day, it's just three simple components. It's a client talking to a server over HTTP. That's all it comes down to. So when we're testing, we're basically either getting, sending, or modifying that HTTP. And if we can successfully do any of these at any point in time, then that's how we actually manipulate this. So for manual testing, it becomes all about that different HTTP, that custom HTTP that we're going to do that. And the way we do it is basically we insert ourselves as man in the middle between the browser and the server. And the easiest way for us to do this is with a proxy, something like burp or zap. And it functions extremely well because when you launch it on your computer, you tell your browser to not go straight to the internet, to go to burp, and then burp will send that information to the server. And that gives you a lot of leverage because one, it shows you all the traffic, even encrypted traffic, and I will show you how you're going to add a certificate in order to see encrypted traffic, because what happens is the browser encrypts the traffic between you and burp decrypts it, and then burp re-encrypts it and sends it to the server. And that's what the definition of a man in the middle is. Does that make sense? So burp, zap are web-focused man-in-the-middle type proxies. I would add one more to these that they've recently released a fantastic version. It's called man-in-the-middle proxy, MITM proxy. The one thing I like about MITM proxy is it runs on the command line. So if you're stuck somewhere with no visual interface, then man-in-the-middle proxy is a very cool one because it runs all within the actual context of a terminal. So it's kind of cool in a pinch. It's a very good tool that does the same exact stuff that burp and zap do. Another good thing about burp is it acts like a DVR. So basically you can record, you can replay, you can pause. So all the DVR stuff you can do with your web traffic, which makes it kind of cool. So most of the attacks rely on us sending weird requests to the server. One of the biggest parts of being a pen tester is thinking outside the box and always thinking like, what happens if I send whatever something that's not supposed to go there? So you say it asks you how many I don't know how many items do you want? You go, I don't know, zebra, something of that nature. Always be out of the box. The answer should never be the obvious one. It's always the one that people least expect. And the better you get at that concept of sending random, strange queries, the better you get at pen testing. And that's known as fuzzing. That technique There are books and books on fuzzing. There are multiple software written specifically for fuzzing alone. Google spent, I think, a couple of years developing something called Hung Fuzz that runs on multi-component CPUs in order to be able to send the maximum amount of ridiculous input to applications in order to see where the application breaks and where they can actually target those vulnerabilities. So that is a science of its own, but the biggest factor to it remains the same basic principle. I call it think perpendicular. Like, if it asks you for something, give it what you think is completely the wrong answer or something that doesn't work. One technique in fuzzing is very common is if it says, oh, just like, enter a name between 12 and 15 characters, the first thing you do is you enter 300 characters. If they don't have proper input sanitization, if they don't have proper thing, this will make the application break. And that's the simplest one. Breaking the application doesn't have to be confidentiality, doesn't have to be integrity. Remember, it could be availability. So if you hit availability, you bring the application down, that's also damage. Does that make sense? All right. TLS tampering gets a little tricky. So we're going to have to trick our browser into thinking that burp is a legitimate application. Once I show you to do this, I do instruct you to be careful when you do it publicly on public computers, because you can be exposing whatever you add the trust to anybody that is using burp, especially if you're using the default certificate that comes with burp. Luckily, I think the newer versions of burp, they randomize the certificate, so it's not the same everywhere. Yes, the number one rule in cybersecurity is never trust input. Never trust input. There is never a source that gives you trusted input. Not one time in the human history. Oh, no, this is coming from the database. I control the database. No. There's a DBA, there's a sysadmin, there's a guy that manages the database. If somebody in the database got exposed to the internet by mistake, if they put in one wrong parameter there, that breaks your entire application from the inside. Input is never to be trusted. I would say any input that interfaces with your application is to be trusted, is not to be trusted. This is becoming known as zero trust. They're even implementing it on infrastructures today. So even when networks, a network will not trust the device, even though it sits on its own network, until it proves it's worthy. So zero trust is very important to be able to never assume there's something that's known as the good path or the path that is allowed for my people or my devices or my applications or my components. It's always untrusted, because if something changes on one of these components, it compromises the integrity of the entire application. So far, so good? Let's go. All right. Finally, cross-site scripting. So cross-site scripting is basically when an attacker is able to get the victim to run their JavaScript in the context of a site that they do not own. It's kind of a confusing name because it says cross-site when it doesn't have to be a site. It's just JavaScript running in the context of that it's not supposed to be run in. So it's basically escaping same origin policy. If you are able to run code and bypass same origin policy, then it's game over. You can do anything that that user can do on their web browser. And that is extremely, extremely dangerous. It is a type of injection. I've heard a lot of people in the industry say, it's like, oh, no, it's different. No, it is injection. You're injecting your code into an application that you don't own or a browser that you don't own. Does that make sense so far? We're going to dive a little deeper into this. So basically, in a cross-site scripting attack, the JavaScript is smuggled in one shape, way, or form into your trusted DOM, and then gets to manipulate it or even see it. And JavaScript can be limited. It can be across the application, or it can be as limited to just picking the actual cookie. If I get your session cookie, I am you for all intents and purposes to chase.com. So this is the #1 targeted thing in the world, is the cookie. At one point in time, Firefox released, I think it's still there, a plugin called Firesheep. And what Firesheep did was it sat on the network, listened to all the traffic that was not encrypted, all the HTTP traffic, and stole all the cookies, and then gave them to you in the form of access. So it'll say user X is using Facebook, blah, blah, blah. User Y is using Twitter. User Z is using Pinterest. And then steals their session because it's over HTTP. And then you can go and interact with those applications as that specific user. It was as easy, and you can Google Firesheep. It was as easy as that. It's a very dangerous thing where you can gain control of somebody's cookie or session cookie, and that's typically what most cross-site scripting attacks go to. So if you do bug bounties and you say, hey, bug bounty, I can do an alert one, or I can execute some JavaScript, the first thing they will ask you is, can you pull a document cookie? That brings up the risk. If we remember, we talked about the risk. So the vulnerability is there, but then is the exploitation there? And the exploitation, does it actually affect me? And that brings up the risk much higher. So basically, the attacker tries to insert code into Chase's website. So when you go visit Chase, you're actually running the attacker's code. And the attacker is going after your cookies, APIs, control your screen. There's a whole framework called Beef that allows you, if you have cross-site scripting, to take full control of the browser to the extent that the JavaScript allows. So you can, like, browse pages from there. You can use them as a botnet. You can even control their camera. A lot of all the different APIs that JavaScript has access to. There are three major types of cross-site scripting. Typically, the most common one we see is reflected. Although that said, it's been changing today and it's going more towards DOM, and we'll talk about this in a second. But reflected JavaScript is very, very, very common still. So basically, reflected JavaScript is within the application. I find a way that when I send my GET request to insert some JavaScript into that request so that the server responds with the JavaScript executing. How do I do this? So the attacker needs to get you to click on a link. So there has to be some phishing, something in place. And it basically learns that at chase.com, if I get you to go chase.com/myJavaScript in a certain field, and if you click that link, then that goes with your GET request. It gets executed on the server responds with all the details, and the JavaScript comes back and executes within your browser context. Does that make sense? And that's known as reflective because it goes and comes back within the same GET response request. It doesn't have to be in the actual link that the user gets you to click on it. It can be, for example, if the user can affect a third party that Chase is using and then load that code from there, or it's in a component that Chase is using or anything of that nature. Second technique is stored. And basically, if I'm using Chase and I notice, let's say they have a forum where people discuss things. This forum allows you to paste, like Reddit. Take Reddit. I think Reddit is a good example, or Facebook. So you post something and people get to see this something. But if there's JavaScript, then I can embed my JavaScript in my post. And if you remember, JavaScript is transparent. It's invisible. People don't see JavaScript. So what happens is I insert this invisible code into my post. So then anybody on Facebook or Twitter or Reddit or whatever, whenever they visit my post, they're actually visiting my JavaScript and executing it. And this was actually effectively done on MySpace for the older people on here that were using MySpace back in the day. A dude, I forgot his name. I think his name was Sam. Just put JavaScript in his MySpace that if you visited, it actually got you to add him as a friend. And then that JavaScript got ported to the profile of the user and then added all his friends as friends. This dude accumulated, I think, 1.2 million friends in the span of 48 hours.
I've heard about that story on YouTube.
Yes, and that's exactly what it was. It was a stored JavaScript, posted It's there anytime anybody visits the page, the script executes. So stored stored XSS is the most dangerous one because it affects anybody and becomes part of that website. So if you're operating the website, you are distributing malware through your website unknowing, which is why protecting against stored cross-site scripting is very, very important. Does that make sense? And then you have DOM. DOM is a little more complex because DOM executes within the DOM. So DOM based cross-site scripting only executes within the DOM. So the only person that can infect himself is you. There is no reach out to the server. The server gave you the application. The server says here's up the JavaScript. You get it. But then you go and click a link or execute something that a friend sent you, like an email or something with a JavaScript attachment or whatever. And that executes in the browser, and it executes in the same DOM where you are actually there, based on the payload that is sent to you. So DOM is a little harder to convince people to do because it has to be a lot more manipulative on the specifics, and you kind of have to do it to yourself. Does that make sense? Because there's no server involvement. The server gave you the code, they're no longer involved. Everything is loaded in your DOM, and then it's a matter of you going and doing something that's bad that executes. Protecting against DOM can be done through like some different manipulations and checks, but for the most part, is a lot harder to protect against DOM because really it's the user doing it. So it's an action you have very little control over versus reflected where the server sees the JavaScript, right? Or the server sees the JavaScript. The server has no vision of it. It's all executed client side. Makes sense? I know this one is a little complex to get, but because of its complexity, attackers have been hitting it more and more today because it's one of those where like people unsuspectedly fall for. Alert one is the most common JavaScript payload on the planet because it's the most basic. So you'll see when you write code that a lot of stuff gets encoded, a lot of stuff gets escaped, and so on and so forth. So special characters become very hard. So when we say alert one, it's just trying to say that we're trying to get the browser to execute the most basic code, and it's visual. We get to see it. That said, it doesn't really demonstrate severity. I don't know if I have access to the cookie. I don't know if I can use quotes or quotation marks. I don't know if I can use semicolons. And if I can't do all that, I can write multi-line JavaScript, so I can't actually do real damage. So alert one just confirms that there's potential injection. And one thing to keep in mind is most browsers today will suppress JavaScript cross-site scripting on your behalf in some instances. So you might not be able to see the alert one. They're starting to backtrack on this because they realize that if you take out the visual component of it, people might not know they're under attack or they might be missed in testing. Make sense? So better payloads would be something like window.origin or document.cookie or document.body. You can like get or like I think window.start to local storage. So you can pull. And you can put a for loop and go in the local storage and just go like randomly over all the local storage within that actual stuff. Does that make sense? But that's why you see alert one and all that. If you go to OWASP has a cheat sheet on cross-site scripting with like about like, I think 30 payloads on that. And you'll see all of them use the payload alert one just because it's the easiest and the most visual and another website, if you want to keep in mind, and I'll try to write notes and send you these, is Payload All the Things. Is a website that keeps track of all the payloads for all the things, and they do a very good job. So you can go cross-site scripting, and it'll go like, here's all the ones I know, and people contribute to it all the time. So it's kind of a good one to go for when you're checking for these. So all that said, what does cross-site scripting basically, what can it do? Well, it can do it can bypass same origin policy. So for me, it's game over. You can do anything that the browser can do, anything that the JavaScript in the browser can do. So you take control of all the things, APIs, cookies, storage. Typically, most people will go after cookies and local storage. That's the number one sought after thing. Cookies, not much you can do about because you need to use cookies for session management. Local storage, that's why we highly advise do not store sensitive information in local storage. And if you're going to store sensitive information, make sure you kind of protect it with either encryption or something of the sort, where you have to have server connection in order to be able to decrypt that information and actually retrieve it. So you have to be careful with that. The other one is it's very commonly used today in botnets. It's used for two things today. One, it's using AJAX without your consent. So basically, it executes HTTP requests for you, so that if an attacker is attacking entity B, it doesn't show their IPs, it shows your IP, and then the FBI will come and knock on your door and like, hey, why are you attacking entity B? So they'll do that. That is very common today, and this is manipulated through botnet frameworks. So they'll try to get as many as they can out of these, like 5,000, 10,000, 15,000 machines, and they route their traffic through that. The other one is, and it's become super common, is crypto mining. A JavaScript crypto mining code can be around 25 lines of code. That's it. I insert it into your browser. I spike your CPU up to 100%. I get you to mine Bitcoin for me, so I make money off your electricity bill. This is today, I think, has become the #1 attack when it comes to cross-site scripting, because if you mobilize 10,000 machines that are Bitcoin mining for you, you're rich.
Hey, I have a question.
Yes.
For the first example you were giving, was you alluding to basically like DDoSing, essentially?
Yes, it could be DDoSing, and it just could be hiding your tracks. It is used in DDoS a lot, yes, but it's more typically it's for what depends on the level of the attacker and the end game. It could be DDoS, but it's sometimes moved just like, to hide who you are, where you're coming from, stuff like that. Because it comes from a domain to a domain, there's no trace back to IPs, and then you hide it, and then you hang around. If you've heard of SolarWinds recently, they kind of use similar stuff. They hid in domains in AWS, so through multiple jumps on cross-site scripting, so the data looked legitimate at certain points in time. Summary of cross-site scripting. It's basically injection. It's code injection, content injection, whatever you want to call it, it's injection. One thing to keep in mind and it's disastrous, that sometimes cross-site scripting will be limited to HTML. A lot of developers will say, well, we need HTML, so we're going to allow people to enter the HTML. And then there's well, they can't get access to the cookie, they only get the HTML. So what I've seen people do is be super creative and inserting HTML that creates a page within a page that takes over the page, and create stuff like clickjacking and whatnot, or other components. So any code injection should not be whitelisted. And we'll talk about the defenses of these a little bit forward. Because it's coming from a trusted source, the browser will trust it. Same origin doesn't apply, which sucks, but that's why I stress same origin initially, because if you have to same origin, at least you protect that portion of the browser. JavaScript can be super powerful if they take control of it. It can be super powerful as well if there's no controls done on the browser. If JavaScript, I can tell you, if JavaScript is run on the operating system directly, you can take control of the full operating system. JavaScript running in modern day browsers can still escape its own sandbox. There's actually a competition that happens every year. It's called Pwn to Own. And that competition pays, I think, in the millions for hackers to be able to string different vulnerabilities using JavaScript to escape the browser. So you can read every year the write-ups are phenomenal. So if you want to read something like this. So yeah, basically cross-site scripting means you have full read-write access and execution within the origin that you don't know. Any questions? All right. Mitigating cross-site scripting. So we go back to never trust any data ever. So basically, if you allow any data to get inserted, I can almost guarantee you that that data might actually be manipulated and then cause cross-site scripting or some kind of injection within your code. So not trusting any data. Anytime there's any input whatsoever, be it from a source that you know is fixed, you have to be very careful with that. Even you can put restrictions on it. Input validation. I cannot stress this enough. One of the best ways you can do input validation is regular expressions. I like regular expressions because they work across the board. They work on Windows, they work on Linux, they work on Mac, they work on across platform, across language, so you don't have to learn it every single time. That said, every single language has input validation controls. .NET does a fantastic job. Python does a good job, but I highly recommend regular expressions on top. You don't even need to learn regular expressions. You can just go get regular expressions online. One thing to keep in mind, it's not the end all because regular expressions can be manipulated still. It just needs a much higher level of skill to manipulate a regular expression, like a much higher. We go from like a script kiddie, somebody that's like, average security attacker, to like somebody who really knows what they're doing. Second one is sanitization, or known as blacklisting. So basically, blacklisting is remove anything that's not needed. If you're asking a user for their username or like their first name and last name, there's not going to be an ampersand or a wildcard in their name. Like I've never met a Johnny Star Love. Like this, like that's not a real thing. But there are people with apostrophes in their name. There is a Michael O'Brien. So with the blacklisting, it becomes a fine line of like allowing people to still write their names like they should versus what characters are not to be there. Blacklisting typically goes after special characters. So there's a lot of characters that you should be on their like bad no-no list, like you should never allow. But there's some that you have to compromise on. The biggest one, in my opinion, is output encoding. HTML, URLs, the DOM, they all have the capability to encode. Python does that as well. So basically, it says that every character is referenced by its output encoding. So that way, there's no way for input to make its way out into the code because it's always written in a different format from the code. Right? The code 99% of the time is written in ASCII. The encoding typically is written in a format that's maybe ASCII that's in hex. Typically, we don't recommend you do ASCII and hex because there's still ways to circumvent, but you can do it in HTML encoding, which is a separate encoding format that is immediately recognized. So if you see on the lower left side, that's a sample of how Django can escape special characters. Like a less than would be an ampersand, LC less than, LT less than, semicolon. Single quote would be something and. So this is HTML encoding, and it's important to use because that you cannot insert code with and LT semicolon, and it's immediately recognized. It's very important. I cannot stress encoding enough. It's a very, very cool, very easy thing to do. Frameworks, any modern framework will probably do this for you unless you disable it. Like they will do it for you by default. Never write untrusted content into the DOM. We see that a lot. Like some people want to manipulate the page, so they allow a user to enter some input and then they actually show it. This is the definition of how JavaScript actually gets implemented. So if you take a username and then go like, hi, Pascal, well, I'll put script, like script alert1 script. And then on the next page, it's like alert1, not my name. It's not hello, Pascal, it's alert1. So, if you input sanitize, if you escape, my name can be script alert1 script because it's escaped. I hope that is making sense because I know it's a little bit complex. DOM Purify will help you do that. You can check it out. It'll actually like show you how it's done and actually create bindings with the variables to encode them and escape them, and do that on your behalf. So if you're writing JavaScript, that's one that'll be. There's like a ton of libraries that do escaping. The important thing is to remember that this exists. The important thing is to remember to do all three things on this list. Is like input validation, don't trust data, and by that we mean input validation, standardization, blacklisting, and then whitelisting the input you need is actually much better than blacklisting, and escaping that output. Sorry, any questions on this? On XSS altogether?
What's the difference between the whitelisting and blacklisting?
So blacklisting, you say semicolons are not allowed and everything else is allowed. Whitelisting is saying I only allow numbers and characters. So whitelist is a subset that you're only allowed to use from. Blacklist is a subset that you're not allowed to use. So we like whitelisting because it confines the space more. So if you say alphanumeric, that means it's only 62 characters. It has to be, A through Z, capital or small, and then the digits. But if you blacklist and say no semicolons, then they might find a way where say hash, ampersand, semicolon, whatever, dash, and that'll be a semicolon translated by the browser.
Okay.
Any other questions? All right. Another one is cross-site request forgery. And that's a smidge of a bit more complex than cross-site scripting, but it's still kind of similar. So the idea is that to the same origin policy, things that are loaded from Chase or like Google should not be loaded into Chase, or things loaded in Chase should not be loaded into Google. Same basic concept, same origin policy, protects origin. CSRF, or cross-site request forgery, commonly known as CSRF, is basically a way to bypass it, but to get the user to bypass it for you. So as we know that requests and cookies are always sent, and they are the exception to SOP. So CSRF tries to abuse both these specific components. So since we can't run JavaScript, but we can send HTML, the idea is to be able to get the user to send that request on our behalf using HTML and execute whatever we need them to execute. This is where the CSRF lives. So basically, the anatomy of a CSRF attack is it needs the user to be changing something. So it's not a GET request. It's either a PUT request, it's either a POST request, or a delete request. The user has to be changing something on the server, because if they're only getting something, that doesn't do anything for us, unless that GET does a manipulation of some sort, which is typically not the case. So it has to have like cookie-based authentication or like some cookie state session in order for CSRF work. If there's no cookie, CSRF has no use. The whole point of CSRF is getting you to run a piece of code using your session token to what the attacker wants to do. The third one is, in order to do this, we need some form of user interaction. The victim must visit my site or click a link. I need to get them to do a specific action in order for them to, using the same browser, to go to that second website and execute what I want them to execute. So it basically abuses HTTP stateless nature because the server cannot distinguish what a legitimate request is from a forced one. So if I force you, or if you click my link and I do a request to chase.com to do a transfer, the browser will still run it because it doesn't realize that this came from a separate entity because you clicked on the link. There was an action by you that actually went to do this. The browser's cookie behavior is even worse because that's automatic. You're not even doing anything. So if I know that if I go to chase.com/transfer Pascal/10,000 will transfer 10,000 to Pascal, then all I have to do is get you to run this link, right? So what I do is I either push that link to you, or I send you to my page with this page. In my page, I go do the request on your behalf in some way.
Oh,
Again, go ahead.
as far as doing that attack, are there any telltale signs that it's happening other than just, I guess, you logging your request yourself, or does it leave any trails that it's happening to you?
No, it's most of the time it's invisible because especially with cookies, it's invisible because it's automatically sent. But it can't happen on its own. Like a CSRF will not. Well, if you visit a website that you're not supposed to, it might. But then you have to visit that website, which is why visiting malicious websites is a dangerous thing to do. But it's still, even if you're visiting the site, they still need to find a way to bypass SOP. So most of the time, a CSRF will come in the form of an actual link for you to click so that it can execute in the browser in rapid succession. Does that make sense?
A little bit, yeah.
Yeah, but no, there isn't any like real method of detection. The server, on the server side, you can put detection mechanisms, and we'll talk about like, synchronizer tokens for CSRF specifically. Okay, yeah, that's it. Basically, it tries to bypass SOP by going through HTML requests. It doesn't do any JavaScript. The whole idea is to run it within the HTML HTML interactions. So this is how it goes. Attacker says, hey, click this link. You click the link. This is the CSRF. You go to his website. You get the HTML. And then in that HTML, when it comes down to your actual device, they just send the post. So when they send the post, it's like, go get this. Your browser automatically appends the cookie because it thinks that you want to send the cookie to the actual site. So if you're doing Chase, they'll create this whole custom elaborate HTML, and then you add the cookie, your browser adds the cookie voluntarily. So whatever they wrote as that execution will be opened using your browser, and the cookie will be sent. This all happens within the browser. Does that make sense? So yeah, that's the reliance on the CSRF attacks. Most CSRF attacks are either authentication based or execution based. So there's always an action that's going to happen. That's what you target. Here's an example payload. So basically, if Chase account transfer expects two fields. You see on the right side, we have input hidden so that the user doesn't see it, and the name 2. It's basically the value, the bank account, or in this case, let's say Ratnop, who's running. And then the second value is the amount, and it says $1,000. So basically, you put some JavaScript that says onload, execute CSRF, and submit. So it'll automatically fill this form, do this, all this. So when you click the attacker's CSRF example, this comes down to your browser, right? In your browser, this gets executed. So you get pull the code. Once this gets executed in the browser, the cookie is automatically appended. And then this gets executed as if you are going to Chase and saying, I need you to do this, this, and this. And the only thing that's different is the type is hidden, but the server doesn't care if it's hidden or visible. It's still the same form. At least it should be the same exact form that Chase expects. So this is a simplified version. Typically, Chase expects a million things. And that's why if you add a new user on Chase, there's a 24-hour period to make sure that if somebody's executing on your behalf, they'll send you an email and tell you somebody's added this, so that you have that visual component that somebody's running this on your behalf. That's exactly why they do these controls. It's specifically for CSRF type attack. Make sense? All right. So this is, in the end, this is what it will look like. it'll be from your browser, going to account/transfer, sending your data information, sending all the cookies that you have in place, all the stuff in red and blue. And then in the body, it says to ROPNOP and the amount. And this is all automatically generated by the browser, the cookie appending. So then it goes, and then Chase thinks, oh yeah, this is coming from the user. He's already authenticated. He's giving me all the cookies. This is everything I expect. He wants to transfer money. I'll transfer money. Again, this is extremely simplified. With banks today, they are super paranoid. But there's like, we see a lot in e-commerce. When you check out, there's not a lot of checks. Like you can do like, one-click buy and stuff like that. So because the server is super helpful with cookies, what we try to do is we try to get the server to verify the request in another manner. So on top of a cookie, what we do is typically we send what we call synchronizer tokens. So basically it's a random value, something with high entropy. So something that is like, not easily guessed. And then when the form is submitted, the server takes that token and makes sure that it matches what they have on the server side, right? And then that says, okay, I have this. This is the thing I gave him, and it was executed within a 60-second time frame, or or like 120-second time frame. I'll allow this transaction to go. And the reason timing is very important, like 5 seconds, 10 seconds, 15 seconds, is because somebody would actually request the page, try to steal that synchronizer token, and then go and upload it again. So it becomes a multi-stage process. So the way to do this is have a time window for the synchronizer check in order to make sure that that matches. So if we have same origin policy, that would limit CSRF, because same origin policy has to be executed on JavaScript. So if you apply JavaScript within your requests in some shape or form, same origin policy has to apply, and then CSRF fails, because CSRF can't execute on your behalf automatically because there's JavaScript, and then the browser goes, hey, this dude is coming out of nowhere trying to execute JavaScript over here. I'm not going to let him, because same origin policy says he is not you. He is not the same website. But then that means you have to make sure that you have JavaScript that's executing, not just adding JavaScript that's executing within your code. And that way, whenever you do a submission, the JavaScript has to execute, SOP kicks in, CSRF cannot work. Makes sense? So, okay, as we said, JavaScript will make SOP apply, which actually stops it. You can do synchronizer tokens with double submit cookie. So basically, it's a random value that's submitted in a cookie, and it's submitted in the body. And I have a picture, like I have a screenshot of this later on that you see. So basically, JavaScript reads the cookie, looks at the body, and makes sure that they match to make sure that they actually are the same. So that way, because the attacker does not have cookie manipulation on your behalf, he will need to know it in order to put it in the body for him to be able to execute CSRF on your behalf. Another one would be custom headers. This is just a random header, which we submitted with every single request that is also matched on the back end. So basically, that way you can do it with JavaScript or any other way, or even do it on like an infrastructure side on the server side and the framework, basically. Third approach, which is not really an approach, is don't use cookies. No cookies, no automatic submission, no CSRF. That's rough because you have no session, but hey, if you can live without that, then by all means. Makes sense? The double submit example, that's one of my favorites. It basically says, and this is what I said when I'm talking about Django in the beginning. Django middle tier CSRF will do this on your behalf. Every time you have an input form, it'll go and append a hidden CSRF token in that form on your behalf, so that when it's submitted, it has to match it. Does that make sense? So basically, in this case, we're putting JavaScript. JavaScript sets the token. The token gets appended every time that we go and click submit form. And then because of this, SOP applies because JavaScript is being executed, and then it is actually validated. So in this, go ahead.
So when you're talking about double submit with the token, is that kind of similar to like a public and private key where you have I guess the keys are constantly changing between each request, or is it something completely different?
So it's not public and private. It's not asynchronous. It's synchronous. So it's like this screenshot says. So basically, because the cookie is automatically submitted, we can add the CSRF token in the cookie, so it gets automatically submitted. And then we can add it to the body. These two things are sent separately. The headers are sent by the browser. The body is sent by user manipulation. So if an attacker is trying to send this, he will need to guess what the CSRF token is because he can't see it. So if he can guess this, he will add it to the body. And then if they match to the server, then it is correct. But if you have a CSRF token that's a little bit complex, it'll be very hard for the user to guess what this is. Does that make sense?
It does. Yeah. Thank you.
No problem. So yeah, it's all just, this is known as double submit. It also works. And then you can also do some protections on JavaScript not being able to actually access the CSRF token as well. One thing to remember is same origin policy defeats CSRF. That's a very important one. There's also you can always put in Angular. I think there's a way to do the CSRF token. There's like a lot of, and React as well has like its own framework methods. So different framework developers have come up with different like weird hacks to do this, which is kind of cool. This is from Angular. So Angular basically sets a custom header. And if you see on line 22, there's, sorry, line 21, it says set request header x CSRF token. And there's like a random entry in this that will be generated, that will be sent by the server every time that the page is sent. So this changes regularly. So basically, only JavaScript can set the header. So you have JavaScript enabled. You're actually putting the CSRF token there, so it has to be triggered. So SOP has to be triggered, and that way you get protection. And then if that custom header is not does not make it to the server, then you can actually validate that it wasn't the form was not submitted by the same initiator. And then it was sorry, if the header makes it to the server, let me put it more in the header makes it to the server, you can make sure that it was sent from the same origin. Does that make sense? But if the header is missing, then you can easily ignore it, because if it's missing, then it was manipulated and you can easily disregard the data. Make sense? This is what it looked like over the wire. Basically, just the CSRF token in the header that gets processed by the browser, and then it gets processed by the server as well on the other side. And this is all transparent to you, at least the user. To summarize, basically, here, cross-site request forgery abuses HTML and cookies in order not to invoke same origin policy. So try to bypass it with like limiting the actual structure. And then it does this by relying on cookies being automatically sent. So it relies on cookie-based authentication, cookie-based sessions. And then the other one is sending HTML forms and requests so that there's no JavaScript and same origin policy doesn't apply. Yeah, it allows an attacker to do that without invoking SOP, and that's the biggest thing. I know I've said same origin policy so many times, but I can't stress this enough because it's like one of the major components that people tend to miss. Any questions on this? And I'm sorry, I know I'm going really fast on these and in the topics. We are going to share the slides, so you get to take a look at them later on. There's also, when we get into WebGoat, they'll go into details on the explanation of each of these. So that's also a good way to get into these. Injection. So injection's been the number one. I classify cross-site scripting as injection. I think OWASP separates it just because cross-site scripting has become a thing of its own. Like it's everybody and their mother uses it. So so it's got separated into its own like magical thing, but it's really injection. Injection is a server-side vulnerability. It's basically the server has to receive some data, put it in the code, and somehow respond to it to the client, either synchronously or asynchronously. Same options apply. Never trust input, because that's where injection stems from. It stems from input. Typically, we say user input. Doesn't have to be user input. I can't stress that enough. If you're taking input from another API, from a machine to machine, or anything else, make sure you vet that input as it comes along. Even if it's a company that's trusted that you work with, because if they're compromised, and then it becomes a supply chain attack. Injection comes in like a million different forms. SQL injection, command injection, server-side template injection. There's a lot that can be injected in different areas. Most common one is SQL injection. And I honestly cannot believe that I've been doing this for, I can't remember, 15, 20 years, and I still see SQL injection. And the reason we still see SQL injection is just because it's the easiest thing for the developer to do, to make the mistake of. SQL is basically writing a query. Select star from a table where condition equals whatever, right? And we all expect the username to user to supply their username. But SQL injection happens when the user does not supply their username. They actually supply something that's malicious. So they either supply their username, they append it with an apostrophe, which, just to be clear, the apostrophe is the % violator of SQL injection. If you want to know if there's an SQL injection, single quote. Try that. If the application errors out, 99% of the time, there's an SQL injection happening somewhere. Number one thing to do is blacklist it. Number thing to do is escape it. Same applies like for when we talk about cross-site scripting. So in this example, what RopNop is doing is basically supply their username. They added an extra quote, and then they said, or 1 = 1, which is a condition that's always factual. 1 is always equal to 1. So basically what they created is they created this condition that says, if username is equal to RopNop or 1 = 1, if either of these conditions are true, log me in. Because this is what this statement is going to do. It's going to go select all the users where the condition is true, and the condition is true always. And if you see towards the end, he did a double dash, which means comment everything after this. And then basically when the code is executes, the remainder part of the code, the quote, the semicolon, and anything that comes after that, like sort by, order by, that gets eliminated because it gets quoted out. So that's the definition of what an SQL injection is. Does that make sense? All right. So basically, SQL injection lets you escape a normal query and inject your SQL parameters. And there is a million things you can do. People think SQL injection, you can just steal data. No, 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 no. With SQL injection, you can do almost anything, because on the server that you're running, it's running SQL. That SQL has an SQL engine. That engine is either MySQL or Microsoft SQL or Postgres or whatever engine you're using. And all these engines allow some kind of even operating system execution, because it's needed sometimes for developers to go and run some customizations. So if you have SQL injection, you can actually enable that functionality, give yourself execution on the operating system, and then gain the actual server. So the escaping out of SQL injection is much easier than XSS is escaping the web browser. The web browser is a fortress compared to an SQL engine, because the SQL engine is not expecting you to reach it. It's expecting multiple layers of protection in front of it, which a lot of people bypass. There's a tool called SQL Map. SQL Map is, I would say, an industrial strength attack tool, because it can take one small SQL injection and do all the work for you. What it'll do is it'll try every single type of vulnerability within injections, and then try to get you all the data, database names, usernames, hash passwords, command execution. You can tell it what you want, and it'll go try to do it for you. It's a phenomenal tool. I highly recommend you play around with SQL injection when you have the time. Unfortunately, it's a massive Swiss knife for SQL injection, and we won't be able to delve into the details of what it can do. Same methods apply. Do not trust user input. Escape everything. And there's one feature on top over here that you can do that you can do with cross-site scripting is with SQL, we highly recommend using stored procedures or parameterized queries. So these database engines, they give you the option to pre-compile the code. And then what that does is basically, instead of that select statement to be actually constructed dynamically at runtime, it's basically pre-compiled. So if the user gives it semicolons or whatever, it just fails because the code is pre-compiled. It's not being executed on the fly. So then you are protected to a certain extent. There are still escape ways out of stored procedures and parameterized queries. But then again, we're talking about top level, like a level 10 hacker, which is something there's not much you can do about, I guess, at that point. There's like some stuff you can do, but then the cost becomes astronomical. The other one, which is phenomenal, and Django does a phenomenal job at, is ORMs, object relational mappers. So what these do is they do all the protections for you, and they map the objects to the database. So the database becomes an abstract thing in the back end that you don't see, and then you just say, give me user object, and then just give me where people's name is this name. And it'll do all the filtration, it'll do the actual parameterization of the queries and everything on the back end for you. And if you're not using Django or whatever, you can still use something like SQL Alchemy. There's one for almost any language. SQL Alchemy is an ORM as well, and it'll do all that translation for you, so you don't have to worry about it. If you find yourself writing an SQL query in like raw SQL in the code, that's just wrong. I can tell you right now, 99% chance that will get abused. Never. There's not just all select statement. There's no, I once had a client tell me, well, this is just a select statement. There's no where condition. So where's the input going to come from? And I went literally the table, and he's like, but how? And I showed him that in the same database, there was a potential to store a JavaScript, and then that query just pulled the JavaScript as is without escaping. So the formatting is, yes, you can use a select star without a condition in the code itself, but the fact that it's dynamically executed is not a great thing to do. Most frameworks today will do all this on your behalf. Just most developers don't know that this exists. I would highly recommend whatever language you're working with, go check what kind of abstraction, they're called SQL abstraction layers. Check the SQL abstraction layer. Not only will it do it for you, it'll make it much, much, much easier. Learning curve is just a little bit higher at the beginning, but once you learn it, it becomes much easier. I see there's some stuff in the chat. Oh yeah, we can. I think if you guys are tired, we can break after. Let me see. I think there's a couple of slides. Yeah, I think that's it. So we can break after this since we finished SQL injection. We'll break before cross-origin resource sharing. Take the lunch break and then reconvene at around 1 o'clock. All right. See you guys later. All right, so now that I hear the recording in progress, you go. I think we can go ahead and start. So this is the last vulnerability we're going to talk about today, cross-origin resource sharing. So we've spoken a lot about same origin policy, SOP, same origin policy, and same origin policy is fantastic in limiting access. it sometimes is too restrictive. So developers want a way to be able to circumvent same origin policy for specific components. And that's exactly where cross-origin steps in. So the idea for cross-origin resource sharing is basically being able to loosen some of the same origin policy for specific components within your application. Sometimes you have an API server, sometimes you have an image server, sometimes you have different servers you interact that you want to allow the similar access to the same origin or the policy or same origin policy that you have for your actual initial application. And this is what cross-origin resource sharing is, or CORS. It's most commonly referred to as CORS. So CORS is basically a way to allow different browsers to interact as if they are, to allow different domains to interact as if they're your domain. They can be subdomains, they can be external domains. A lot of people see CORS and they immediately think this is a vulnerability. It's not. It is by design, it is functional. Problem with CORS is half of the time it is misconfigured, which turns it into a vulnerability in itself. It's a very powerful tool, and we learned a lot about same origin policy. So when we loosen that same origin policy restrictions, we have to be extremely careful who we're loosening it for and for how long. So whenever cross-origin JavaScript request is made, the browser needs the service response in order to determine how it can allow it. So there's four important headers, or major headers that you use. It's basically allow origin. So who are we allowing? And this, I think the biggest thing is it allows wildcards. So you can say allow star, and that'll allow all the internet. You can say allow star.google.com, and this will allow everything from google.com to interact as if they are you under the same origin policy. You can also do methods, and I don't know how well you're familiar with this, as we spoke about them a little bit, but that's the get, post, put, delete. So you can say allow get for everything, but don't allow post or put. You can also do specific headers. You can say allow to set cookies, or allow anything that a header, like it could be security header, it could be any cross header that you use, it could be referral headers or anything of that nature. And then you can do credentials, as in explicitly send cookies with the actual content. So this is all decided by the server. The browser will comply with whatever the server tells it to. That's why misconfiguring any of these headers can be disastrous. Specifically, that top one, access control allow origin, that is the biggest culprit. Because this tends to break people's code when they're working with multiple domains. So you do it in test, everything's on the same server, and then you push the production, everything gets spread out to 4 servers, it breaks. I've seen this over and over and over again. People would just go star, just allow everything. And that basically just shreds the same origin policy to bits, and you circumvent your own security that was put in place for you. So depending on the cross-origin requests, the browser will make a decision after the fact. So if there's nothing overly complex in how the course is being constructed, it'll be treated as safe. So treat it as is. The browser will send it, but it will not return the response to the page unless there's an explicit header that allows it. For something that is a little more complex, there's a pre-flight request, as in there's a request response sent before it actually is allowed or permitted. So instead of the request response immediately happening and setting it up, then we send something called an options method, and it's basically sent to the server first, and we see how the course headers are set. Then the browser will make a decision on on the second request or the original request. So this is known as a pre-flight. So we send a check, and then we tell the server, okay, what are you allowing? The server tells us what it's allowing, and then we make a decision based on the response from the server. Does this make sense? All right. So we spoke about 4 different headers that are important to us. So here's a message. This says basically allow post, get, and options. The cross origin that we're allowing from is chase.com, right? And then we will allow credentials. So we will allow cookies to cross over, and then allow these headers. So we will allow these 3 headers: content type, origin, XJPMC, CSRF token. That's like typically headers that start with an X are security related. When you see X dash, so these are specifically written for security preempted. So we allow these 3 headers. This will configure the cores on the browser, and this is how it should be used. This is not overly permissive. The allow origin is explicitly set to a single domain, single protocol, because you can circumvent all this. You can reduce protocol, you can reduce domain, you can reduce port, you can just go like anything, any.com. And then we set explicitly the methods and the headers. So this makes it an extremely finite cross-origin resource sharing policy. That is how it's supposed to be implemented. Any questions on this so far? All right. So sending a simple course request, it's as simple as get this a public/account, and then the API server will set the policy on the way back. The browser will block the response data from reaching the requesting page because the header does not allow it for that specific domain. So if we're reaching out to api.chase, we're from a website called attacker.dropnop.dev. Because the actual domain dropnop.dev does not match chase.com or actually the full thing, then it'll be stopped. The browser will make that decision to stop because it makes the calculation. There's a mismatch in the identification, so request gets basically denied. On the pre-flight request, it kind of does it preemptively. So that policy goes, the options goes like, is this allowed, is allowed, everything's set on the browser. And even when the attacker tries to run it, there won't even be a response because this is pre-configured in the first place. The pre-flight request has already set up the cross-origin policy in the first place. So the browser doesn't even bother to send it. So in the earlier case, this gets sent, we get the policy back, we match against the policy, and we say, oh no, you're not allowed to see this. The decision making is done by the browser. And in this method, when the pre-flight is set, the browser makes the decision not even to send a post because it knows that it doesn't match malicious or unmalicious. It just doesn't make its way through. Make sense? Wildcards. We spoke about wildcards. If anybody has any previous networking experience, the wildcard is akin to an any-to-any on a firewall. A lot of people get tired on firewalls. They don't want to put the rules anymore, so they go any-to-any. Just let everything flow through. This used to happen a lot back in the old days. And this is the same exact thing. So this basically says allow anything to read from the server any credential, so any cookie token. So wildcards should not be used for third-party, public, unauthenticated data that you don't own or domains that you don't control. Another thing I've seen is misplacing stars or wildcards or asterisks in the domain. So you can say star dot, let's say you own 123java.com. You can say allow origin from star.123java.com because you own the domain and you probably have ownership over all the subdomains and you want to allow access. And that somehow is correct. But I've seen it done the other way around. I've seen people be lazy and say, allow origin 123 java.star. And that is very dangerous because a lot of people compute, like they say, oh, I own the .com, I own the .net, so I'm really not worried about it. But in that context, it's very important. Anybody can go get a website, any domain. And like say I own pascalisa.com. What I can do is I can create a subdomain called 123.java.pascalisa.com. And that will match the policy. Because the SAR doesn't say a single domain or a single entity after the dot. It is any string. So being careful with that wildcard matching is very, very important. And that's where most people do their mistakes. Also, a lot of people sometimes skip protocol. So they don't do HTTP or HTTPS. There's manipulation there. Sometimes it's an explicit path you want to allow. So you have to be careful in how you said this. This is what I'm trying to say. So I think I'm beating a dead horse at this point. Does this make sense? Any questions on that?
I think it'll make a lot more sense if we can actually see like an example in action or something.
Yeah, we're gonna see some code. I think we can play around with this on WebGoat as well. I think there's a course example in there. Biggest problem is, as I said, developers will always try to find a way to circumvent this. Wildcards is the most common way. Oh, and just so you know, I don't think I've mentioned this. Browsers, if they see an overly permissive course, like Chrome will sometimes deny the policy if it sees an overly permissive course policy. Like if it's **, allow credentials, it'll be like, nah, this is not happening. It'll ignore it. So browsers do some of this at their own discretion. Really bad anti-patterns happen when either people don't know what they're doing, they don't bother to read the manual, or their like construction of what a domain or an entity or a method is allowed is misused. So that's the number one culprit of anything with allow control access, origin or content or anything of that stuff. So this is why it's always good to set. It's always better to set more headers, but if nothing else, access origin and access content is access origin, access credentials, and even methods if you can. These three, I would say, as much as you can. Headers tends to be an iffy one because headers shift between different servers, and different server headers might have a load balancer, and that might mess things up. And this is what it looks like. Sometimes, because of the circumvention, what happens is people circumvent it in a different way. So instead of just allowing access origin for a specific domain, what they do is they set this automatically. So the server sets it based on whatever the initial origin is. So if my initial origin is foobar-123, it'll set it to that. But if my initial origin is pascalisa.com, it'll also set it to that. This becomes very easy to spot. Actually, you don't even have to worry about it because Burp will spot it for you. If Burp sees a reflective, dynamically assigned cross-origin allow origin, it'll immediately flag it for you. It'll do that analysis for you on the fly. So doing that dynamically is a very, 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 very bad practice, and you should never do that. This is what it looks like if an attacker is trying to actually gain access. If you set the course dynamically based on the initial source, like in this case, the attacker got dropped off the dev, this will grant them permission, effectively bypassing SOP. Which is why it's not a good way to do this. Even though there is programmatical ways for you to allow you to dynamically assign domains based on your needs, you have to be careful. It has to be a subset of domains that you control. Mitigation is basically understanding when you're loosening what you're doing and set explicit access. It's very important. I personally will flag most wildcards except for maybe subdomains. But that's become a problem setting them with a lot of places. So my typical recommendation is don't use any wildcards unless absolutely necessary, because there's more than just the asterisk. There's like different ways you can actually circumvent that. Another thing is make sure to set all 3 headers that we spoke about together, and don't disable CORS just because it doesn't work for you that way. It's a very useful tool if you know how to use it effectively. Any questions on this?
When you say subdomain, and don't use wildcards, you're talking about like a star dot, like website I control.
Yeah. So if you do star dot domain.com, depends on your browser. If there's no slash towards the end, you might be able to do, so if you do star.123java.com, I might be able to do pascal.123java.com.pascalisa.com, and that would still match.
Gotcha.
So understand how the browser is running it. Sometimes the slash towards the end makes a difference. Sometimes it's a dot. So I forget the exact, I'll be honest with you, I forget the exact syntax, but that was something I would definitely look at and check before I deploy. That's basically it for CORS. Any questions on CORS before we move on and start working with burp a little bit? All right, we start working with the fun stuff. Were you all able to download Burp Suite? Anybody had? Okay, cool. I see thumbs up and nodding heads. All right, so were you able to install it?
Yes, sir.
All right, so I'm gonna do a presentation walkthrough on Burp, and then I'm gonna do a small Burp walkthrough, and then we're gonna make sure that everybody's able to follow. I'm gonna pause at every single one of these just to make sure that you guys know what's happening. So Burp is installed. Can you all start Burp, please?
Yeah, I downloaded it. I wasn't able to install it, like I said in the chat a while back.
Why were you not able to install it? Is it the Mac DMG one? It'd be a little harder to do the exercises if you don't have Burp up and running. I guess I can help you once we start, when we go into lab time, when we go into actual hacking exercises. All right, so if you started, just choose a temporary project. You can set up a project if you want. Temp is just much easier, much quicker. Use Burp default since this is probably your first time using it, so don't worry about that. And then when you get to the interface, click on proxy, which is the 3rd tab, which should still be the 3rd tab, and then click on the intercept. And you'll see that intercept is set to on, so it's going to stop any traffic that flows through. And then you can do either open browser, or you can set up your own browser. So I think I have one for configuring Firefox. So Burp added Chromium to the actual application. So if you click open browser, it'll open a browser that's already configured to use Burp as man in the middle. So you don't need to do any setup. But you can also, in Firefox, I like to use Firefox because Firefox allows you to set a proxy on Firefox alone, while Safari, Edge, Chrome will set up a proxy across the entire computer, which is something that will start passing all your operating system traffic through Burp as well, which is something you typically don't want to do. There's a lot of like proxy extension packs called like Foxy Proxy and Proximator, and like there's a bunch of them that'll make it easy for you to switch between Burp and not Burp, Burp and not Burp. But with the embedded version, it makes it much easier. I now use the embedded version to open Chromium, do all my Burp testing there, and when I want something that doesn't want to go through the actual man in the middle, I go through my Chrome or Firefox or something else. Sorry, for something else. All right, you guys still with me? You can follow this. You opened Chromium, it worked. All right, nice. So then in the intercept, just in Chromium, just go to Google, CNN, Reddit, anything, your website of choice, and you see that the screen pauses. The browser doesn't open anything. If you go back to burp and you go to proxy and intercept where we were, you see that intercept is on still, and you see what your browser just sent. Right? You can either forward this, you can forward them packet by packet every single time to see everything that's happening at every step, or you can just remove intercept and go to HTTP history and see the flood of traffic that goes through, just by one simple example of visiting something. All right, still with me? Any questions? It might fail on TLS. I don't know if you get the failure with Chromium. Actually, let me check that as we do. Start burp real quick. All right. I want to see if it fails. I can't remember. Yep, it should do. So you shouldn't have a TLS failure. If you have a TLS failure while using Chrome, that is something is wrong there. It should not fail. But if it does, if you're using Firefox, you can easily install a certificate from burp. Just go to proxy options, click regenerate CA certificate, and then click import export, and then export that certificate by just clicking certificate DIR format, name it in a location you can remember, and then just save it. Then just go to Firefox. And in Firefox, you can go to settings, you can go to certificates, and you can say install new certificate to trust, and you install that certificate. It's a complex one. I can help you set it up if you're unable to do it, if you're adamant on running Firefox. But if you don't, if you're using Chromium, that should all be done for you. All right, you guys still with me? You're doing good? I'll still walk through this by hand just to make sure that we all see everything in live traffic. Now, if you go to HTTP history, you see everything. You see every single request response that server that Chromium is using is being sent over this. So you see all the history. You see it all decrypted, and that's the scary part because you are terminating TLS on both ends, and you are able to decrypt the data, see it, and then decrypt the data and send it. So it's scary stuff. Burp Suite has a ton of functionality. There's a book called Burp Suite Essentials. There's also the best thing on the planet called Burp Academy. Sorry, Portswigger Academy. Burp Academy. I can't remember. It's on Portswigger. It's called either Portswigger Academy or Burp Academy. They have 150 different exercises on every single vulnerability that exists, including the 4 that we spoke about, with a ton of detail, a ton of documentation, and a ton of exercises and CDFs to do. I thought about doing that for this class, but I figured it's going to be a little overwhelming because it's like there's a lot of data there, and we don't have a ton of time to do that stuff. So I figured it's better to do something a lot easier with WebGoat. It gives you get your foot in the water, as they say, foot wet, and then you can go ahead and play with Burp Academy. Another website I can't say enough good things about is pentesterlab.com. Pentesterlab is it .com or .org? I can't remember. But Pentester Lab is a website that has 2 tiers. About 50% of it is free. So all the basic stuff, all the initial stuff, all the Linux basic, XSS and stuff is free. And then if you want to go a little more advanced, they go advanced. If you want to buy the license for Pentester Lab, they do a 50% discount every year on Black Friday. So I would wait until November to get the pro version. I think there's enough free exercises to keep you busy for a year. But if you really like it and want to support them, I would wait until Black Friday. All right, so we've already spoke about intercept. We spoke about history. We're going to talk about like sitemap and what you see, and then some other functionalities in there. Intercept is very cool because you can basically, it's a DVR and you're hitting pause. You saw the traffic, you click pause, and you're like, oh, okay, I see this. And then you can manipulate it on the fly and click forward, and it'll change that packet and send it. And burp is super cool. It'll keep both packets. It'll keep the original and the one that you modify, so that you know what you modify, just in case you forget. If you come back 3 days later, you actually see both of them. You can drop the request.
I got a question.
Go ahead.
Sorry, I didn't mean to interrupt you.
No, go for it.
But can you like go over like what a proxy is?
Oh yeah, so a proxy basically is a man in the middle. So companies use it because sometimes they want to watch your traffic or they want to cache the traffic. So proxy has a lot of good uses, typically. It stands between the client and the server, and it monitors all the traffic. Companies do it, some ISPs do some proxying stuff. It happens a lot. In our case, a proxy is an attacker that's a man in the middle. They have access to all our traffic, which is, I can tell you that if an attacker gets in that position, it's very advantageous, and there's a very good chance they can actually hack whatever you're doing. There's somebody raising their hand, Kyle.
Yeah. Do companies use proxies to kind of determine like where, like to kind of trace like where trackers could be potentially accessing from, like as far as like traffic goes and everything like that? Or is that a little bit farther down the line?
So they do it for a couple of reasons. So they do it for traffic analysis to see what you're doing. If you're doing, some companies would like to see if like, employees are going to sites that they're not supposed to, or if they're spending too much time on Facebook, because proxies also can monitor how much time you spend. They also use like malicious detection. So if you're visiting a website that's known to be malicious, it'll stop you. And it'll have TLS termination. So if you're siphoning company data, they can actually watch. So a lot of government entities will put a proxy and it's put something called the DLP, a data loss prevention mechanism, in the middle. And then it'll watch that traffic, and it does something called deep packet inspection. So it looks really deep in the packets, so in the data, to see if you're actually sending code or if you're sending, HR information or stuff of that nature.
Awesome. Just another quick question. So I guess theoretically, right, like you have to access a proxy to get onto the internet to access certain websites, things like that. So really, like incognito mode really doesn't do anything.
No, it doesn't. Incognito mode basically stops the browser from seeing all previous history that you have within the browser. So if you visit the same site, same origin policy doesn't apply, because incognito establishes a new policy. So even though you've visited Chase before, your credentials are not available in incognito mode.
Just basically user protection, right? Like as far as like your data and everything.
Yes. Yes, it's mostly so that the browser doesn't record any history and doesn't give websites you're visiting any access to your previous history.
Awesome, thank you.
Yeah, if you want actual anonymity, you do Tor. Heads up, if you do Tor, in some countries, you're immediately suspected of doing something illegal, even though Tor is not typically not necessarily used for illicit activities, but unfortunately, it is 80% used for illicit activities.
What about, let's say, using like a VPN and stuff, because that stuff has been marketed like all over the place.
So VPN will protect your identity from your ISP. That's about it. But your VPN provider can still see everything. Well, not everything. So anything that's TLS is encrypted. A company's proxy to work successfully, they have to install a certificate on your computer. And you remember in this step where we forced the certificate on our browser, a company has to do that for you. But on a computer that's owned by the company, this is very easily set through group policy. But if you look in your certificate store, and I can show you that in a bit, you'll probably see your company's certificate. Like if I open my Firefox or my Chrome, I'll show you my Cisco certificate, which I always get yelled at because I go and delete it, and then they get very upset because they don't watch all the websites. They watch some websites, and it makes them very angry when I visit the website and it circumvents the actual certificate. So now they changed the policy. If I hit these websites and I don't have the Cisco certificate, I'm not allowed access anymore. That's how they sorted it. They're like, hey, you don't want the certificate, you don't get access to the website, which is fair. I mean, I am using a company computer and a company network, so makes sense. Any other questions on this?
VPN. So I've heard like in some countries you even have to have like a license to have a VPN. That's just really to kind of access a network and really just transfer data securely, right?
Yeah, I mean, so yes, I used to live in Dubai and Saudi and Qatar for a long time, and you do need a license there because the reason is porn is illegal in the Middle East. So believe it or not. So in order to stop that, they stop all VPNs. Any company that has a registered VPN IP, that IP is blocked. So you're not allowed to hit it. So you won't be able to make a VPN connection. But at the same time, companies like I used to work for Symantec back then, Symantec wanted me to connect from Symantec Dubai to Symantec California, but they didn't want my traffic to be public over the internet. So I had to create a VPN tunnel. So Symantec Dubai had to go register as an authorized VPN operator in order for me to be allowed to use that.
That seems pretty difficult with like business continuity and actually getting work done. Like if you have to access like an external like network, right?
Yeah, so that's why, but they allow big companies to do that. So they allow it. It's just you need to register that you're a VPN, and it's not like an individual user. They also worry about like like stealing country secrets and dissidents and terrorism over there. So like they like to watch most of the traffic. I can tell you in Dubai, if you use Tor, so Tor is a little difficult to spot on the network because it's TLS over 3 different tunnels. But if in Dubai, if you were using Tor and they figured that out, you immediately made the watch list.
That's insane.
Yeah, because they operated on the principle that if you're going to these lengths to hide what you're doing, you are doing something illegal. That's the general notion of operation.
So basically like guilty until proven innocent in that regard.
Pretty much. That was I can tell you from my experience in the Middle East. Yes, that was most Middle Eastern countries will do that with the. I mean, there's no action on it, unless. But I can tell you, you'll make a watch list, which is annoying in itself. You might not notice it, but like the fact that is there. But it is what it is. Different countries have different rules, and that's how they operate. So. All right. Any other questions on anonymity, hiding your tracks online? What do you guys want to do online? Now I'm a little worried. I'm teaching you all this. Huh? All right.
We're nothing but upstanding citizens here.
I sure hope so. But yeah, even if you're gonna use Tor, you need to VPN before you use Tor because you'll be giving Tor your IP, and there's like a lot of stuff around that. So IEFF, if you're interested in this stuff, there's I forgot what it stands for. Like it's the frontier for privacy. I think
it's like the Electronic Freedom Foundation or something.
Electronic Freedom Foundation. Thank you. That would have killed me. Electronic Freedom Foundation does a lot of work in helping you maintain your anonymity online, and they help a lot in countries like the Middle East specifically. They do a great job at helping people being able to tunnel without having to go all through all the loops. All right, back to Burp. I don't know why they changed the name Burp, but like I think it's hilarious. Okay, intercept, history. Just go to history. You can add something to scope so that you can limit the history, because it shows you all the traffic that flows through. But if you're interested in one specific site, then you can limit that traffic to site and show you that traffic. And I'll show you this a little bit hands-on in a minute. Decoder is a very cool tool. It'll do all the decoding from all known formats. So you can say decode from HTML to plain text from base 64. Base 64 is very commonly used, specifically with cryptography, because cryptography has non-visual characters. So they have to be encoded in order for us humans to see them, but the computer can understand the binary. ASCII, hex, octal binary, you'll get used to these as you go along. You'll see a lot of URL, base 64 to HTML. These three, a lot. Sometimes you'll see a little bit of hex, but like URL, HTML, base 64, these are the top 3 for sure. Repeater is a beautiful, beautiful, beautiful tool that has saved me a lot of work. So that's the part of the reason why I love Burp so much. Repeater is very simple premise. I'm sending this request. I just want to change one letter. I'll change one letter. I click send. It shows me what happens. I go back. I change a couple letters. I send it. It shows me what happens. which is very cool because I can do it. It gives me full flexibility on changing whatever I want to change hands-on. And then there's Repeater's big brother, Intruder. And Intruder is basically like Repeater, except you can change a field and you can say, I want to try all 9,000 combinations from 1 to 9,000 and this specific field, go run them. And Intruder will go and throw about 100 requests per second. I ask you, please, in the demo, I'm running this on my own small, tiny server. If you do like 100 requests per second, there's a very good chance that my server will tip over and we will have to rebuild it or like restart it and so on. So please go easy on this. There's 20 people hitting a small server. So just like approach with caution.
Talk about
right.
denial of service.
Yes, pretty much. The server is not set up for this many people. So it's going to be a little slow. I apologize about that. So before we jump into WebGoat, we can directly jump into WebGoat, or I can give you a small demo, like a live demo of Burp, if you want to see it first. Up to you guys.
I'd say live demo just because we're coming out of installing it. It'd be kind of cool to see what exactly we're doing with it.
Yeah, let's do that. All right. Let me do a share screen. Can I do full screen? Yeah, I think this is it. All right, let's do Burp. Where's Burp? Sorry, there we go. All right, let me start it from the beginning. All right, close this, close everything. All right. I have Burp Professional because I'm fancy and my company pays $400 for it. So that's a nice perk. I started a temporary project. You can do a project. If you save the project, Burp will save the instance every 30 minutes. So that in case anything happens, you always have a safe state of everything you've done. Again, don't forget, this is a DVR. If you leave this running for like 6 weeks while you're watching the traffic, it'll fill up your hard drive and everything will collapse on itself. Use Burp defaults. You can have your own configuration file. Once you get comfortable with Burp, you can say like start Burp in a certain way, and you can change colors and all that stuff, and then you can do all that. Burp's dashboard is very cool because it's like basically the end all. It does everything and shows you everything that it has detected all in one place. So every so often, come back to the dashboard. It'll show you what it thinks is wrong and is right and all that kind of stuff. Target is where it shows you the sitemap. Scope, you can add to scope and remove from scope. Anything you add to scope will limit Burp to only see stuff in scope. So when you add the first thing into scope, that will be the only thing that's in scope. Everything else will be ignored. So be careful when you add it. It'll actually tell you that. Issue definition is a very cool one because it tells you what it's looking for and what it is and how it's actually identifying it and so on and so forth. Proxy is all where proxying magic happens. Always starts with an intercept on. Just hit that magic open browser. I can't tell you how like super helpful this is for people who are starting with Burp, because setting it up initially was like a little bit of a pain. So this is kind of cool. And then just hit, I think my page is called Code Platoon. All right, see, nothing is loading. You see it's stuck. That's because I have intercept is on. So it's like, here's what I'm doing. I'm trying to reach out Code Platoon. I'm like, okay, allow it. And goes, oh, the page cannot be saved. 1 second. I need to actually start. And the reason I have Code Platoon stopped right now, or they get WebGoat stopped right now, is because it's a very vulnerable application. If I leave it on the internet, somebody would have hacked my server in under a day. So this is just going to go up for the time we need it. Let's see. Sure. All right, let's make sure that it's running, starting. Seems like it's running. And I have a reverse proxy, so I can see some of the traffic coming in and being able to block it whenever I need to. And now if I hit it, it should come up. There we go. Ooh, no, okay. So it says not secure because it's man in the middling it. My certificate is actually secure. So if we look at the history, we see how we actually tried to get to it and how it actually immediately redirected me and everything that was executed all at the same time. I'm going to come back to this a little bit later just to show you like basic man in the middle for this. I'm just going to go over the rest of the burp stuff for now. All right, so let's say I like this, like the login stuff. I can say, okay, let's try sample login. All right, you can see the login, try. You can see my username and password that I actually entered. And then it says not found in it. So I can do right click, send to repeater. This takes me to repeater, it fills this in. And then I can say, okay, try this password. And it says, nope, you can say follow, 302 is a redirect. You can say follow redirection. It's like, nope, it's not there. Follow redirection, goes back to the initial page. Beauty of burp is you can see the raw data that's returned. You can also click render and act as a browser and show you the page that it got. I think that's very cool. So you don't have to jump back to the browser every single time. So you can see it whichever way you want. This is how the computer sees it in hexadecimal format. Sequencer, I'm not going to get into. Sequencer basically checks if the tokens you're using, the session cookies or anything, any crypto can be sequenced. If it's weak, and if burp can make sense of it, then it'll actually start generating those sessions for you and say, oh, this is weak. I can create one of these. And the server will accept it. Intruder is pretty much like repeater, but it says, okay, any areas you want to change, you say, okay, anywhere you add this weird squiggly symbol, let's say the password, say add, and then you say, okay, payloads, I want to do ASD, I want to do . You can paste a full list. There's a website called SecLists, which is perfect for any kind of list that you can think of, usernames, passwords, all kinds of stuff if you want to try it. And it says the payload count is 2, you want to try it. I say start, it'll start the attack and it'll run them both. This won't run because we're actually, the target is example.com, which is not a real target. Same thing, you can send to intruder from here, and then you can do the same thing. This will actually work. So if we clear all the setup, we can add. So it has multiple different techniques. So sniper is one change at one time. Battle ram, it change multiple things all at the same time. Sorry, pitchfork would change everything at the same time. Battle ram will change 1. Cluster bomb will change everything all the time. Cluster bombs are massive because there's a million different combinations that I can try. You guys still with me so far? Phenomenal. Decoder will do decoding. I can say Pascal Isa, what does that encode that as, I don't know, base 64. And goes, oh, in base 64, it looks like this. And I'm like, okay, let's clear this. Let's clear this. Okay, what is this? Decode this base 64 thing. And it comes back as Pascal Isa. That's why encoding is not encryption. It's because the math can easily be done and you can do it. You can even do a cool feature in the newer version of burp is you can do smart decode and just click smart decode and it'll try to figure it out. Well, it didn't work this time, but it sometimes will try to figure it out. It's not working. Anyways, but yeah. Comparer will compare two different things. Logger will show you everything you've done so far. Extender, you can add a lot of different additions into burp. There's people that write their code and to detect, for example, additional CSR checks or like SQL injection. I think SQL map has a full-on integrator. SQL tampering, SQL map DNS collaborator. There's like a ton of stuff you can do, but that becomes a world of its own. Project options is like specific to the entire project that you want to do. If you want to overwrite anything, you can also do authentication, proxy upstreams. It gets a little complex just because these things like authentication, it'll grab the authentication, like the login mechanism, and replay it every time the server asks for authentication. So you don't have to do it yourself. That's basically burp. Makes sense? Any other questions on this? All right, we can, if you want, break for 10, 15 minutes, or you can go ahead and jump into it. We're gonna do a couple exercises. I would say have your pick from whatever we learned today. So here, let me show you real quick. All right, I don't think I've registered the user. It has to be an easy password. This is, again, a vulnerable application on purpose. And if you read this, it'll tell you, like, this is a really vulnerable application. Don't attempt to run it online. WebGoat you can get from OWASP and install anywhere you want. So I highly recommend giving it a look. You can run it in Docker and play around with it at home. It's very easy setup, really. It's not. You just basically download a Java file and you run the Java file. They also have a Docker image. There's a code repo. I think it's OWASP/WebGoat or WebGoat, and it'll tell you everything how to do and how to run it locally. Yeah, don't run it publicly. That's not smart. All right. You can see WebGoat goes after the top 10, OWASP top 10. I would recommend doing the cross-site scripting, and it goes through different steps to tell you what the concept is. Anything that's read is an actual exercise. I highly recommend having burp open so that you can see the actual traffic flowing back and forth. And you can actually replicate what's happening and how it's happening. Cross-site request forgery is the last one as well. I would recommend you doing something like this. I don't know if there's a course or and I would recommend doing an SQL injection. I think let's skip cross origin for now. It might be under XSS or CSRF, but for now I would recommend doing picking one, just and whatever you're comfortable with, whatever you think you understood better than the others, and going with that. Again, please have burp running when you do this, because you need to be able to see the traffic as it goes in order to see what's happening. Even WebGoat will tell you to look at your proxy at some points in time.
How do I get my my burp site to start letting me search stuff?
Sorry, what was that? How do you get?
Yeah. You open up like your terminal and like wrote some code to let your burp site start going to like URLs and such. What was
Here?
that code? Yeah.
Oh, that's the WebGoat start command. It's this line over here. So I can share this in the chat. I need to start putting a lot of the stuff in the chat for you guys. I'll do it when you start working on the CDF. So you need to download the code first and run it. Again, make sure to run it locally. I'm running it on you publicly so you guys can get access to it and start messing around with it. Just make sure when you run it on 127.0.0.1. That's your local IP address. Only you have access to it. Burp will still be able to see it. Even if you're running locally, you should be able to see it. All right, we break for 10 minutes. We then start the CDF. Here, let me post this as well. This is the website. If you want to start going, get it right now. We're going to do this for a couple of hours. I say we do exactly what we did right now. We take a 10-minute break, and then we do 50 minutes. I'll take a 10-minute break, and then we do 50 minutes, 10-minute break, and then I'll walk through an exercise or two with you guys, just to make sure. I'm going to be online. Anybody that has a question, ping me and share your screen. We should be able to do it. I don't know if we can do breakout rooms with the Zoom. If not, what we'll do is like you have to share with the entire class as I work through with it.
Awesome. Thank you.
All right, sounds good. Let's pause and then we'll pick it up at 2. All right, I'm gonna be hanging in the shadows. Give it a whirl. Try one of the three we spoke about. An injection, SQL injection, the intro one. Cross-site scripting, there's only one, and in forgery is the client-side request forgery. Let me know if you have any questions. I'll try to do them in parallel really quick. And I'm just gonna go on mute, just like ping me if you need anything.
Hey, Pasquale, I think you're still recording.
Yeah, I think I wasn't the one stopping it. Do you want me to stop this?
We'll go ahead and stop that.
Yeah. Yeah, I can't. I think Tom has to stop it. I don't have start-stop capability.
This is really interesting, though. Thank you for dedicating the time to teach us about it.
For sure. I think I have my email as well in there somewhere. If you have any questions, please feel free to ping me. I'll be happy to help even